Buongiorno a tutti, vi chiedo se è possibile di prendere posto perché fra 5 minuti, anche meno, iniziamo. Grazie. Una comunicazione solo per i tecnici competenti, ricordatevi di firmare l'ingresso, l'uscita a pranzo, di nuovo l'ingresso dopo pranzo e di rimanere fino al test perché altrimenti non sono riconoscibili i crediti.
Squillerà sicuramente, non si deve muovere questa no? Bene. Possiamo cominciare. Good morning, buongiorno a tutti. My name is Arnaldo Melloni. I'm the project manager of the LIFE project EVIA. And hello everyone, and welcome to the final event of our project. Just a few words to thank you for your presence today, and I especially want to warmly welcome to the project partners from Italy, University of Reggio Calabria, IPOL, and Vienna-Rose Engineering. And from Germany, Continental, and from France, University Gustave Eiffel. It's a wonderful working group, and thanks a lot for your contribution. I'm very proud to have coordinated this project, and I also want to thank my colleagues Jacopo Bianchi, Jessica Pecchioni, and Elisabetta Sorelli for the fundamental contribution given to the good performance of the activities. Also thanks to our monitor, Dr. Rosa Clot is here today. Thanks a lot for your support, for your help in every situation, in every moment of our job. The day today will be organized into two parts. In the morning, we will have the presentation and the results, the presentation of the results of our project and the possible ways of continuing continue the activities. And in the afternoon, we will have an interesting comparison with other projects financed by European Commission, and I think that will be a wonderful networking opportunities for us and for the other project. I also bring greetings from Andrea Giorgio, the Councillor for Environment and Ecological Transition, that now is involved in a meeting with our major, and so it's impossible for him to be here. So this is our third live project regarding noise pollution, and we hope to have other opportunities to experiment and share in other projects ideas and a new way to solve the item of noise pollution in the city. I think that these are a wonderful occasion for us to improve our capacity to work in the city. Now we have just ready. We are ready for the.
Yes.
Okay. So Raffaella Bellomini from Vienna Rose Engineering. I think that we can start with our day.
Thank you. Good morning. And I'm really very happy to have the possibility to share this morning session of the final event of our Life EVIA project. And before starting with the presentation and the contributions of the partners who will explain the objectives, the activities, and the impacts of our project, I am really honored to have here directly from the European Commission two representatives. First one is Mr. Zlatko Kregar. He's a policy officer at European Commission in the General Director for Mobility and Transport in the Unit for Sustainable and Intelligent Transport. And then Mr. Marco Paviotti, officer at the European Commission in the General Director Environment, where he deals with the EU policy on environmental noise and urban environment. So I would like to immediately leave the floor to Zlatko Kregar, who will present a contribution about electromobility in the EU. What is the Commission doing? Hello Zlatko, and thank you for being here.
We see, Zlatko, the whole your screen, and with the gray area on the right side.
Okay. Is this better?
Yes, it is. Perhaps just start the presentation and I can give you feedback if it's on full screen. For the time being, we see the PPT window.
Okay. I don't know why is it not going to full screen, yes. Hello.
Okay,
so
now
see.
Beautiful.
Great. So let me again say I'm Zlatko Kregar from DG Move, from the Sustainable Intelligent Transport Unit, and I'm starting with this talk as a general context and a general update on the road transport aspects of our recent policy packages, which will serve as a good introduction to my other colleagues and to the whole event. So let me start. What is our main, where we currently framing our policies in the road transport area. So in 2020, we have had the Sustainable and Smart Mobility Strategy, which defines and basically lays the foundation of how will we transform the transport system, all of our transport systems, to be more resilient, but first and foremost to be more sustainable. So we will aim for a 90% cut of emissions in 2050, which will, like I said, which will be a transformation of the whole transport system. So we have also intermediate targets. Let's not forget that we have in the climate target plan in 2030, we have the target, the emission cut of at least 55%, which links to our ambition to become the first climate neutral continent in 2050. But how do we do it? What's the operational aspect? What are the operational aspects of this strategy? It's the Fit for 55 package. It implements these targets. And transport is a huge part of the package. And it is really defining the transition to biggest, one of the biggest packages ever and the biggest legislative transitions ever. So the key aspects are CO2 standards for cars and vans, refuel initiatives for aviation and maritime, which we are not going to touch upon today, and which interlink with all the ambition in the Renewable Energy Directive. Of course, in the last year, we have had, or this year, we have had a huge transformation and a shock to the energy and the transport systems as well, with Russia's invasion of Ukraine. And in response, the Commission proposed the Repower EU plan, which is aiming to end the dependence on Russian fossil fuels, but of course, to completely be in line with our climate targets as well. So we have increased the ambition in the Energy Efficiency Directive for the Energy Efficiency Target and the Renewable Energy Contribution in the Renewable Energy Directive. The 5 percentage points here, which might look a bit small, is actually a huge increase in ambition for 2030. We have also published a EU SAFE communication looking at short-term behavioral changes that can reduce our emissions and our gas demand and oil demand. But so I'm phrasing the whole situation in the transport sector. But what is, I think, very important for this audience to hear is the next slide, which is the revision of the CO2 standards for cars and vans, because it will tell you that the application of this standard will really define the vehicle market in the coming decades. So we see that the current CO2 emissions standards for cars and vans have already been delivering. We have had in the last full year a surge in share of low and zero emission vehicles, basically from 3%, which is very little, to around 20% in 2021, and it's continuing in 2022. We see it in year-to-date changes. The rate of increase of low emission vehicles is not as high as in last year, but still the share is increasing. We have had very ambitious announcement from all the manufacturers towards zero emission vehicles in their portfolios, either in European ambition or the global ambition. And we see that the global market for zero emission vehicles is really exploding. I'm going to even be more direct than growing rapidly, which I wrote on the screen, is that in China, for instance, we have had the projections have been blown away by the number of zero emission vehicles coming to the market. So this all paints the picture of where we are. The CO2 targets that we proposed in July 2021, the new ones, are we don't have a change until 2029, but nevertheless for 2030, the increase in ambitions is substantial. We're going from -37% to -55% for cars and 50% for vans. And what is important, we have finally set the target for 100% reduction, which means all vehicles registered from January 2035, which many people know that it is somewhat far in the future, but in the vehicle, these are two product cycles, or even less, in the next 12 years. So in December 2034, we will have the last registrations of internally combustion powered vehicles. Of course, this is the way the regulation works. We have specific targets for individual manufacturers. So the target is for one OEM, for another, but they all have to fulfill the reductions. So this is a graphical representation of what I showed on the previous screen. Again, steps are over decades and decades, and we see that the green down there, the new target is minus 100%. So it is the major step that we were looking into. I will also highlight that the new target for 2030, so again, in just a little over 8 years from now, minus 55% compared to 2021 in emissions, does effectively mean that half of the new sales will be, around half, difficult to ascertain now, will be zero emission vehicles in 8 years. So what are the benefits of the strengthened targets? Of course, it's clearly the reduction of CO2 emissions, which is in line with our climate target plans for 2030 and 2050. We have this tightening of the CO2 standards is reducing emissions significantly, greenhouse gas emissions in the 30s and 40s. Of course, because tailpipe emissions of vehicles will be zero, we will have less air pollution and better air quality in urban areas especially. So, of course, the impact assessment looked at the monetary cost and external cost savings in high billions of euros. Of course, consumers will have the cost savings. This was the savings that you see on the screen were actually calculated even before the recent energy crisis. So this changes the dynamic as well. In general, the societal benefits are quite clear, and employment is still positive, whatever the questions. And finally, the innovation in zero emission technologies is great for global competitiveness to keep the technological leadership in Europe of vehicle emissions, of vehicle technologies. Sorry. So this is what we framed. Where is it going with the general market? Many questions that we often get is, how are we going to build up the infrastructure for this? And that's why in my unit, we have the alternative fuels infrastructure regulation, also part of the Fit for 55 package, because we need to ensure that there is mobility across the union to be direct. So we need to ensure that the vehicles that we pushed through CO2 regulation, emission standards, through all the parts of Fit for 55, can be used across the union. Therefore, we have introduced targets for member states for charging infrastructure, for electricity charging, with fleet-based targets and infrastructure provisions. Why is this relevant? Because I'm trying to frame this to show that the transition towards zero-emission vehicles is covered from both aspects of demand and the infrastructure. And we are doing this for light-duty vehicles, LDVs, as well as from heavy-duty vehicles, because heavy-duty vehicles will also be part of a new CO2 standards revision, which is currently ongoing, and I cannot disclose anything until the proposal is adopted and published later this year. But anyways, we are preparing the infrastructure for heavy-duty vehicles, so trucks, long-distance trucks, which will be zero emissions, which will, of course, have impacts on pollution, but as well on non-exhaust pollution as well. So we also have targets for waterborne aviation, which is not the main focus of today. But I wanted to as we framed, where are we going with the general vehicle? Where are we going with light-duty and heavy-duty vehicles? I try to ask some questions in my conclusions of this introductory presentation. Is as we understand that zero emission in mobility is here to stay, it's becoming prevalent quickly, and like I've tried to highlight, in 7-8 years we will have high penetrations. In 12 years, all new vehicles will, for instance, light duty vehicles will be zero emissions. So electric vehicles mostly, but also hydrogen fuel cell possible. These CO2 standards, which are part of the climate goals, are also very well driven by air quality considerations, which my colleagues after me will also highlight very well in their presentations. We can expect that atmospheric pollutants from tailpipe emissions will decrease significantly with increased electrification, or zero emissions to be more broad. This is, of course, for this event is very relevant. This is tailpipe emissions, but we understand that the non-exhaust fraction will remain there, and it has to be tackled differently. Of course, which my colleague will follow up shortly, the noise for electric vehicles will be slightly reduced only, as we know that the main contribution will stem from tires and road surfaces, and especially we have to be. It's very relevant that for instance, the Euro 7 proposal is going to also look at non-exhaust particles as well, non-exhaust pollutants. So with this, I have made a presentation that frames the general targets and the general direction the EU is taking with zero emission vehicles or zero emission mobility. And I think my colleagues will continue to frame the discussion for the rest of the event. So thank you very much.
Thank you very much, Zlatko. And now I will get the word to Mr. Marco Paviotti.
Good morning, everybody.
Good morning.
Shall we go for a Q&A session or now after Zlatko presentation, or do you want me to start with my presentation and postpone it? Because Zlatko, you know, he also will be with us for the next, I think, 15 minutes, and then he needs to leave us.
I'm okay with 20 minutes if need be.
Okay, so we can organize a quick question and answer session after the presentation of Marco, so we can have answering questions regarding both the presentations. So okay. Marco is going to present a contribution. Are tires and road surfaces the best solution to noise? So Marco, please.
I will start to share my screen. Yep. Hold on a second. Is that fine? Can you see my presentation?
It's arriving. Now, okay. Now it's okay, Marco.
And here we go. So thank you for inviting us. My role in the commission is dealing with noise from transport in general. There certainly have been a focus on road transport and aviation transport because of its effects on noise and human health through the noise emitted. I would also like to, you know, moving on what Zlatko said, to get a bit concrete and nuance you know, how relevant it is to look at these numbers that we present over there. Well, the discussions in the last 2 years and in the coming years will be quite intense on the transformation towards green mobility. You see the basic message of Zlatko being, well, we go through electromobility, And I will take over on his last point, which is, well, electromobility still has at least one major, I would say two major impacts. One is the release of the plastic from the tires. The other one is the noise emitted from the contact between the tires and the road surface. And we would like to take this as an opportunity. In our job, we really daily discuss with the automotive industry, with the tire industry, and also with the representative of the road authorities. In Brussels, we are all grouped around the same circle. You know, we meet at the bar, we meet in the meeting rooms, but then there is an effect because these numbers will really translate into legislation. So what Zlatko presented, you know, the Euro 7, which is coming up, is a proposal that is law. It means that even though we don't see the effect today, we know for sure that we'll have an effect in 10 years' time, because if you don't comply with the law, you cannot sell your product. So that's the optic. I would invite you to look at the statement of Zlatko and what I will present to you now concerning are tires and road surfaces the best solution to noise. So a bit of context. We are in the right political context. This parliament and the commission is green, and the green topic is high on the political agenda. We have two main axis of our political agenda, one being called the Zero Pollution Action Plan, and the other is the Smart and Sustainable Mobility Strategy, which I will introduce in the next slide. And we have, in this specific context, one issue, which is noise as one of the three large externalities linked to the transport sector. And you see on the screen here on the right side, the bars for the effect in the three transport area of road, railway, and aircraft, and the cost they have on society in terms of billions. You could recognize that noise is in the same order of magnitude of air pollution and climate change, although being less relevant. While it's still something that if we go for electromobility, that will dramatically reduce the impact on climate change and on air pollution, we still have this main element, which is the effects of noise. And we have already a legal framework in place, which includes a directive, the Environmental Noise Directive, or Directive 2002/49 EC, plus a series of other legislation on the source, for instance, on the cars, for instance, on the tires. And there is, on top of that, national legislation, and there is local legislation. I understand in the room there are noise experts. And you know that, if you're a noise expert, you have a regulation also at municipal level for the noise in your municipality. We did a study. So the number that you see at the end, 357, represents a roughly estimate of the amount of legislation linked to the management of environmental noise that we have in Europe. You can consider this very complex legislative framework in which we need to still not lose our sight of the objective we want to achieve in the long run. And it is because of that in the European Union we also are also enforcing the legislation. And for instance, we still have 10 infringements ongoing against member states for not having complied with the law. Now, going back, as I told you, to the Smart and Sustainable Mobility Strategy and the Green Deal. So the Green Deal is the umbrella under which the whole political program of this Commission is. And there are these two pillars that are relevant for us. On the Sustainable and Smart Mobility Strategy, we have a set of actions related to noise, which are the revision of the Airport Charges Directive, the revision of the Urban Mobility Package, the Zero Pollution Action Plan, which I will explain is on the right side, the taxonomy, which means introducing rules so that if you're a company and would like to borrow money on the markets, then, and you want to say, okay, I am green, then you need to comply with these parameters. And for instance, there are parameters for the compliance of the limits of the cars, of the limits of the tires, and even when you go for public procurement and you change your road surface, for the road surfaces as they have to be. We also intend to develop coherent rules for environmental, energy, and safety performance of tires, against topic discussed here today. and we are developing an aviation label. So you take the plane and you know if it's green or not. On the Zero Pollution Action Plan, we have the main target for us, which is by 2030 to reduce the 30% those people that are chronically disturbed by noise. We also want to improve the EU noise-related regulatory framework on the tires, road, and international level. And we have as an option in the Environmental Noise Directive, if the legal framework as it is now is not sufficient, to introduce noise targets so as to push the local and the national authorities to implement better the necessary interventions. So we said the objective of the Zero Pollution Action Plan is to reduce by 30% the share of people chronically disturbed by transport noise. The European Environment Agency ran a survey amongst the public authorities, and this is the result. So the people believe they are, half and half, say. Half of the people, they think this is feasible, half of the people, they think it's not. You can also look at this graph this way, which remove those that have no opinion, and you see that we are roughly in the center line. So it means that we are on good track. It means this target is a bit challenging, and that's exactly what we want. So we want, not to be over-demanding, but also not to be too obvious. So I think we got it right. The directive that I mentioned is our main instrument, and the directive is a mandatory process, and there's a mandatory reporting to the Commission. There is no EU limits while the national ones are in force. What do they ask in practice? They ask to make maps wherever there is noise, so even below national limits and the reporting threshold set by the directive. And you need to, the local authority, the competent authorities for the roads, for instance, in this case, they need to draft action plans wherever there is potentially an issue for noise. Now, the part of interpretation of the directive, which you see of the right, stems directly from recent judgment of the European Court of Justice that clarified some elements of the directive that could have been misinterpreted by the end user. Now, looking forward, and that perhaps the more interesting part for you, we did recently analyze for road noise what are all the possible options that we have in practical terms, which kind of solutions can we have. And when you have a solution, you can say, okay, that's a solution. So what? There are costs typically associated to that solution. So you need to compare these with the results. And for us, the result is reducing the impact on human health, which is, as you see on the top on the right, annoyance, sleep disturbance, and myocardial infarction. These are the effects of the road noise. Now, to compare the left part and the right part. So on the left side, that was this large study that assessed by different methodologies which are the cost of intervention. For instance, the cost of imposing better tires or imposing to improve the road surfaces wherever necessary in the European Union. And the cost all over the year up to the 2035. On the right side, for the same set of years, you see an estimate of the benefit in terms of health, both calculated as DALYs, which is disability adjusted life years. It's a common standard to measure from the World Health Organization the health, and in terms of relative reduction. What are the results? Here they are for road. This big study, the acronym for those they were in touch with it, it's PHENOMENA. So this big study identified that for roads, the tires are the most cost-effective solution. And then you have speed restrictions. It goes in line with the intention of the public authorities, especially in big cities, to extend the speed reduction from 50 to 30 kilometers an hour. And we are already some cases. This has an immediate impact on noise, and that's a substantial impact of noise. But you can also intervene with vehicle limits. So like Euro 7, we are used to think Euro 6, Euro 5, Euro 7. So these are the limits on the typically mainly tailpipe emission, not the emission of the exhaust of the vehicle. But there is an identical regulation, European regulation, that sets the limits for the entire road vehicles for the noise emission. And operating on that regulation would also give an effect. Or, and here we are again back on the topic of this workshop today, on the quiet roads. So what you see on the right, this is an analysis of the reduction on the health burden when you intervene by different solutions. You can read yourself the ones that you like, but definitely I want you to focus on the quiet tires, on the speed restrictions, and on the national limits, and on a combined solution. In particular, the combined solution ABC, which together give already a great bunch of reduction. And on the right side, you could see an analysis of the cost efficiency, of this intervention. Meaning, if I pay €1 for the intervention, have I more than €1 back in terms of societal benefit, which is in terms of reduction of an impact on health, or have I less than that? And you see when it's on the right of the bar, there's a clear sign that there's an intervention to introduce. When it's on the left side, it's not convenient. So for instance, and I conclude on this slide, on the quiet roads, you see that you have not a good ratio, but that is because if you would go for an extensive use of quiet roads everywhere, then you would probably introduce the quiet roads where it's not strictly necessary. So the quiet roads, therefore, is a solution that you need to intervene in specific situations. Now, we also studied, and from the European Commission, we paid many research projects. And we this year, we launched an assessment amongst all the road noise project paid, so linked, for instance, to the tires, to the vehicle, to the management of traffic, to the asphalts. And we identified which project have addressed which of these solutions. And so it's for you to get an overview of the fact that in parallel to setting rules, the European Commission also funds, by means of hundreds of millions of euros, research so as to enhance the solutions. Live project today, the one of the workshop, it's also one of the projects that was funded partially by the Commission. I think it's about 60% paid by the Commission, and then the other 40% is paid by the authorities. So I'm heading towards the conclusion. Potential of tires and road surfaces. We expect tires to provide around 3 or 4 dB reduction. That's our guess, and based on a set of studies in the last 20 years, meaning that using only the best tires on the market, this is a possible gain. An open question, and the reason why we are facing the debate, the coffee with the tire manufacturers and the car manufacturers is what happens to tire abrasion and what happens to wet grip. They say, well, we can do tires which are quieter, but they will be less safe, and perhaps you may have an effect in release of more microplastics. We will be looking into that. We will be looking into that because we need to identify if these arguments are correct, or eventually if they can be corrected by shaping the production of the right tires. We expect road surface to provide 1 to 4 dB reduction in general tempo. And we know that in exceptional case, you can even go down to 15 dB. So if you have a very bad pavement and you go for the super new pavement, then you have a huge reduction. But we stick to 1 to 4. We have also there an open issue, and is what is the durability and the life cycle cost of that? Heading now to the conclusions. We can say tires have a potential and are the most cost-effective measure, delivering on all roads and at any speed above 30 kilometers an hour. The tires are the only solution for the electric vehicles, and we see we are going to electric vehicles. So in the moment when we will all pay for a transformation of the road transport, we cannot miss this opportunity to also look at the tires, because remember the first slide, the noise is less than air quality, less than climate change, but yet of the same order of magnitude than the other two. And road surfaces are extremely affected and should therefore be used where levels are too high and other solutions are not possible. For instance, barriers, speed reduction. So again, the road surfaces that are discussed today are a solution we need to work on, we need to implement in those places where it makes sense. As these solutions are necessary to achieve the 30% reduction that we have in our political goal of the Zero Pollution Action Plan, then we are reflecting as Commission on how to promote such solution. And I'm now looking forward for your question, while I also thank you.
Thanks a lot, Marco. And I ask if there are any questions. Is there any questions for Marco or Zlatko from the audience? No question. You have impressed the audience.
This happens when you are on teleconferences. I always say we missed the coffee break. Come on, guys, don't worry. We are far, but we can still answer your question.
Okay.
Just, good morning, Marco. Arnaldo. Just, I don't know if it's a question, but I think that it's very important to have a good collaboration between public administration and private company to solve the question. I think, for example, I think that for us was very important to have as a partner Continental in our project, because in your presentation it was very clear that we can work to find solution in our cities, and we are working for this. But we need to have a collaboration by private company, because new tires, new solution in pavements and so on is very important for us. What do you think about this? What can do Commission to improve the collaboration between these two parts of our world?
You can be sitting around the same table and drink a lot of coffee, which stimulates mental activity. No, indeed, I think that you have this project where you share this experience and these partnerships, but it will come because the recent project, they all identified this issue of the interaction between the road on one side and the tires on the other side, and we see, okay, now transformation to the electric vehicle. I see also in the debate that we are having with the car industry, and on the other side of the public authorities, there are two communities. And these two communities, yet they don't trust each other. Let me be frank on that, because I see the community of the road authorities, of the local authorities, they are somehow in our meetings pointing the fingers towards the car industry, and they say, well, okay, you need to strengthen, they have to do more. And then it stays there. And on the
Marco, the microphone.
Is it okay? Can you hear me?
No.
Yes, now
Okay.
yes. We lost 30 seconds.
30 seconds. Whoa. A lot of time lost. Sorry. Then I'll be short. So there is on both sides, there is a bit of mistrust and miscommunication. I think, the authorities, they are focusing on roads. For instance, they think, okay, nothing will come from the car industry. And I've seen this recently. There was a study from the European Environment Agency. And in this study, they used the ministries as a source of information and some local authorities. and they didn't include tire solution because they didn't believe that this will ever happen. So on the other side, you go, you know, the day after, you are in a meeting with all the car manufacturers community and the tire manufacturers, and what they do, they say, okay, these guys, that they deal with local level, they don't take care about the road surfaces, and they start parallel studies, independent, not using all the...
Again.
Microphone. Your microphone.
Yeah, okay, it's there. So the car industry, again, they say, okay, and they are starting now, and I tell the guys, what are you doing? Because they are starting in parallel their own assessment, and they are trying to make a model of how the roads in the European Union could be, and they want to see what is the effect of the vehicles in real life scenario, because they don't trust the local authorities making the map or assessing the noise, you know, in the city or around the highway. So there are two communities that still need to be linked together. And because the problem is solved only if they work together, there is a need to have more meetings. When, you know, one makes the presentation, but the other is there. So that goes somehow beyond the live project. And coming back to your question, you said, okay, this is an example. We have a nice collaboration with our tire manufacturer, and it's nice. What can the Commission do? So what we can do, what we will eventually do, is to organize this kind of interactions so that we can build trust in between the two communities.
Marco, we lost the connection again. No, you're here?
No, I'm here.
Okay.
That was my answer.
Okay. Thank you very much. Thank you very much, Marco. And it's really important that policymakers, decision makers, companies, and road managers speak and dialogue together to find solution to not only to noise pollution, but also to other connected problems and issues that are still open in our world. Thank you again.
I think Zlatko perhaps wanted to intervene.
No, thank you. I'm just going to say another thank you for inviting us, and yeah, this is it from my side.
Okay, thank you again. Thank you.
So Raffaella, what is the follow-up now? We continue the whole day, so we can leave it on the computer to follow the presentations, and
yes.
Yeah, we can stay
yeah.
online.
We continue to the morning, and also in the afternoon there will be a roundtable regarding other projects on the same issues. Okay. I'm quickly going to now introduce main project activities, main impacts expected from our life EVIA project. Our project started in July 2019 and is going to end in January 2023. And there are 4 beneficiaries. The coordinating beneficiary is the municipality of Florence, which dealt with the implementation of the new asphalt in the pilot area. Then from North to South Europe, there are Continental, which dealt with the design, the testing, and the optimization of tires. Université Gustave Eiffel, dealing with the test of asphalt in the new prototypal track area in Nantes. And then there is Via Rosa Ingegneria, which dealt with soundscape analysis and dissemination and communication activities. And IPOOL, based in Pisa, here in Tuscany, dealing with acoustic measurements on field. So they performed and are going, and is now performing noise measurements in the pilot area. And last but not least, of course, the Università degli Studi Mediterranea di Reggio Calabria, which designed the mixtures. Life Via project was conceived in a general framework which is based on two pillars. The first one is tackle noise pollution from road traffic noise, focusing on a new perspective, as Marco and Lasco told before me, where perhaps the electric and hybrid vehicles will be a consistent portion of the flow. And so we try to combine knowledge of road optimization and tire development in order to test and optimize the solution for reducing noise in very populated and very densely populated urban areas. In this slide, I want only to show some position papers and documents going in the same direction of our project. As Marco has just illustrated, we are several document position papers of the policymakers and different subjects working in the framework of the mobility and noise policies going in the same direction. In September 2020, so a couple of years ago, Eurocities, which is, I think you know, it's an important group, network of European cities, published a position paper to aim to give some contributions for the reduction of noise in urban areas. And this position paper is based on three main points. The first one is to propose a general, a green public procurement criteria for road surfaces with noise and pollution benefits, and also a proposal for a regulation for labeling road surfaces in order also to reduce noise and to give also benefits in terms of air pollutions, and also to propose a regulation to give indication on a systematic renewal of tires and road surfaces to accelerate the benefits of the technological noise reduction technologies. And more recently, in March 2022, a group of companies and associations dealing with automotive and proposed another document where they called to European Commission to enhance policies to give a regulation on the systematic use of the low noise road surfaces, in particular in the most critical noisy areas. But going to our project, because I don't want to take time to other presenters, we try to group the objectives of the main goals of our project into 6, which correspond to the 6 presentations we will hear after me. The first one, of course, is related to the general reduction of noise in urban areas and is related to design of optimized surfaces in terms of volumetric and surface textures for mixed fleets where electric vehicles are, as I told before, increasing in number. And then in parallel, we try to develop with the Continental, of course, dealt with this, a new optimized tire optimized for surfaces and electric vehicles. We tested in a new track built up in Nantes the prototypal asphalts with several rounds of measurements, CPB and SPX. And then when the asphalt has been optimized, we laid down in the pilot case here in Florence. We performed also a life cycle analysis and a life cycle cost of this new asphalt to demonstrate its feasibility also in terms of the cost and durability of these asphalts. And then we continue to perform noise measurements in the pilot areas. And we tried also to give a contribution for providing rolling noise coefficients to implement the database of the Knossos directive for electric vehicles. And last but not least, our project is, I think, characterized by an impressive activity of dissemination and communication, and also of people awareness about the issues of noise and relation with health, also by means of the soundscape methodology that we use to involve people and trying to know their perception in terms of the improved quality of noise climate in the area where we laid the asphalt. This is the structure. In this final slide, there is the structure of our project. We moved from the analysis of the state of the art, and then, as I told before, in the lab, great lab work, we tried to find the mixtures. Then we have tested them and optimized them, and then laid in the pilot area. And now is ongoing the LCA and LCC analysis to verify the durability and cost of this asphalt. And then is also ongoing an important action of replication, and we want to replicate as more as possible the results and of our project, and also to exploit the results, and this will be the base for further studies and further analysis. I want to thank you, my colleague of Villarosa Ingegneria, for this work, in particular Sara Delle Macchie for the dissemination, the coordination of the dissemination activity, and Lucia Busa and Gianfranco Colucci for the technical activities, apart from Chiara Bartalucci and Sergio Luzzi that will speak after me during this day. Thank you. It's now the turn of Professor Filippo Gianmaria Praticò. He's a professor at the Mediterranean University of Reggio Calabria, where he deals with road, rail, and airport safety and materials, and his contribution is design of a new low emission asphalt. Please.
Thank you, Ms. Chairman, and thank you to everybody for being here, among a lot of friends of us. And my presentation was supposed to deal particularly with payment and what we did in terms of payment. But I was quite fascinated by the speakers that spoke before me, and particularly by the EU perspective and approach. And if you look behind us at the presentation of Mr. Paviotti, you will remember that the weight of the payment in terms of reduction of the noise was supposed to be quite well assessed and lower than the impact and the weight of other components, like, for example, tires. Now, this is true, but it is a matter of perspective. It is a matter of perspective because from a philosophical, high-level point of view, we need to think to an holistic approach in which we are dealing not only with noise, but with a lot of components needs, societal needs. One of them is noise. Another is, for example, air pollution. Another is mobility. And so when we deal with the mitigation of the noise through a low noise surface, we, at the same time, are dealing with comparing orange and apples. We are dealing with having a payment surface that, at the same time, not only reduces the generation factors in terms of noise, but only have a good durability, have a low impact in terms of rolling resistance, has a low impact in sense of air pollution. And by the way, the same European Union in the life-related calls well represented this need for comparing orange and apples, because they say in the call, low noise surfaces with a low LCC, with a low life cycle cost. And that approach in terms of LCA or LCC is a tool to take into account that when we talk about noise, we need to talk also about the ability of the payment to last. So we need to balance different needs from a certain standpoint, even low generation factors in terms of Van der Pol equation, but at the same time, having a low impact in terms of air pollution, in terms of carbon footprint, and this means having a low LCC in general. Apart from this almost philosophical introduction, let's focus now on the second element of my presentation, the complexity of the scenario and the complexity of the task of the physician, of the engineer, of the medical doctor when willing to reduce the noise impact. This complexity is partly included in the famous Van der Pol equation. We need to work on different kinds of vibrations. Vibrations coming from the interaction between tire and pavement, vibration coming from the interaction between the train, its wheels, and the rail track, and so on. And so, at the same time, we need to consider how these vibrations generated in a certain point propagate, both in the air and in the solids. So we have, from a certain standpoint, mechanical propagation into solids. And so we need to understand if we are talking about S-type waves, C-type waves, Rayleigh waves. So we need to understand something about what happens when a mechanical vibration in its boundaries interacts with the air. So the transformation of a mechanical vibration into a solid into a mechanical vibration into the air. That is to say, noise. And we need to reduce the final impact working on a number of factors. And namely, today, working on primarily on tire and pavement. And after, on the propagation phenomena. Now, let's start to focus on my third concept. Assess that we are talking just of a small part of the big issue, so the reduction of the LCC. How can we work for reducing degeneration of the noise in the interface pavement tire? This issue is quite complex because there is a sort of gap between many actors: tire producer, road producers, and experts in the field, in the environmental field. Each of these cultural entities and groups has a different way of thinking. If you talk with a pavement engineer, to him the noise is just one out of 200 needs. So if we need to design from a practical standpoint something that fits the theoretical needs, you cannot neglect to think to the production process at the asphalt plant, to the production process on site, and to the fact that we could say each door has a different key to be opened. Now, there are a lot of solutions in the literature. And these solutions were born in order to reduce the noise. So when an engineer that works in a municipality, in a province, needs to provide its governmental body with a low noise payment, it could simply go into the solutions that were proposed in the past. But this is just a small part of the big problem, because apart from the noise impact, when it's built, we can say, there is no noise impact over time. And if we have an approach that neglects to understand and focus on the durability, in the end, the overall noise balance will be negative. Apart from the solutions that are really well known in the literature, one could think to focus on having a tailored solution, so the right solution for that street. And so, in that case, in this second case, what are the main principles, the tools for a scientist to go ahead? Does he need to know the type of traffic, electric or ICE, or heavy vehicles or light vehicles? The transportation engineering standpoint, how many pedestrians, how many cars per day? In the material standpoint, which kind of aggregates are common in that particular scenario? Which kind of mixtures are very common in that particular scenario? Is there an overall tool at this level, noise level, to go ahead with a design? Maybe. When you design a mixture into the lab, or finally when you underwent the prototypical experiments as we did in this EVIA Life project, having the design in Reggio, the prototypical proving ground in France, and finally the road in Via Paisiello here in Florence, you need to start from the lab and from the analysis of a lot of parameters. So you need to start from mixed design, but you need to consider that there will be a construction, so asphalt plant related issues, transportation related issues, on-site issues. And you need to consider that you are dealing with the door, but you are not dealing with the key. The door is the payment, the key is the tire. So you need to consider that what you are going to do is just an half space. And when designing this half space, you need to think, you need to take advantage from your knowledge in the field of the other half space, that is to say, the tire. And coming back to the presentations of Mr. Paviotto, you need to consider a lot of performance. So not only the noise, but also, for example, the permeability and absolutely the friction. This theoretical approach is a practical approach at the same time. So one of the issues, for example, that in this project we faced with is just the a sort of antinomy, a sort of issue between two main classes of instances, of needs. From a certain standpoint, having a low noise payment. And from the other standpoint, for example, having a good surface texture. So, which are the tools? You need to think to the overall approach, and you will have, as you can say, can see in the picture on the left, what happens in the asphalt plant. So you need to start from the asphalt plant. You need to start from the gradation. You need to start from combining different gradations in order to obtain the right texture. So we are talking about one of the main actors in this complex tool, the surface texture. But the surface texture that must be seen not as the starting point, because it is just the last point of a process. We cannot look at the surface texture in terms of mean profile depth, in terms of power spectral density of asperities, without thinking that at the asphalt plant you will need to select the right gradations, the right aggregates, and the right, these factors are absolutely linked to the context. In the sense that when you think to producing a mixture here in Florence, you will have different parameters, different from the ones that you will face in Bolzano or in Palermo. This, why? It is simple, because we are not talking only about sides, so gradations. We are talking about of coarse aggregate angularity, fine aggregate angularity, and we are talking about asphalt binders that are different. So, the flow chart from what happens here in Florence, in the asphalt plants, and the final results in terms of hands or close proximity index or other noise-related indicators is captured by this flow chart and passes through the centrality of the texture, the surface texture. The surface texture that, going back to the Van der Pol equation, affects the generation factors. But at the same time, this surface texture is related in some way, to a certain extent, to the air voids content. So in this strategic scenario, you need to consider at the same time how your choices are going to impact on the generation factors. This is to see what the close proximity index understands and listen to, but also to the propagation phenomena that will be dominated by the air voids of the mixture, which in turn is linked to the surface texture. So when you approach the issue in terms of texture, at the same time, you are dominating another important factor, that is the absorption, the acoustical absorption. And in this overall scenario, the noise absorption is just 1 out of 1,000 parameters. What matters is the final result. So there is no time to go in detail about my presentation, but I tried to summarize the point of view starting from the high-level analysis in terms of LCC, going towards the complex scenarios in which we have vibration in the air and vibration in the solids, and so boundary phenomena. And finally, I would like to conclude with one of the 1,000 existing relationships between the power spectral density of the asperities, in a word, the texture, and the way to control it at the science stage, in the lab, in the asphalt plant. So, on your left, the result. On your right, the means, the tools that a medical doctor, an engineer, a scientist in general can use to obtain that the left side of the equation lowers its entity. And with that, my presentation came to the end.
Thank you very much. Thank you very much Filippo, for your very interesting presentation. I'm not sure the microphone, oh yeah. And it will be time for question and answer during the round table in the afternoon. So I kindly ask to the audience if they have questions to take note, and then we can discuss during the afternoon. And the next speaker is Mr. Carsten Hever from Continental. He's working as tire mechanics and noise and vibration engineer at Continental, and his contribution is about holistic low noise tires for electric vehicles.
Yes, thank you, Rafaela, and warm welcome to everyone also from my side. And I'm happy to have the opportunity here today to present about our work to a wider audience. I'm sure there are many among you who are not experts on tire road noise, so maybe I have the opportunity to change that a little bit so that you're a little bit more expert at the end of my presentation later. And I want to start quickly with giving you a quick introduction about who we as Continental Tires actually are, and to give you an idea of why we have been interested in contributing to this live EVIA project. So as Continental Tires, we are about 1/3 of the Continental Group, where we have also other segments, vehicle networking and information, and autonomous mobility and safety. So these are other sectors within our companies who are basically providing automotive solutions to the automotive industry. And then we also have ContiTech, which is a supplier of rubber products for industrial applications, you could say. Looking at Continental Tires, we roughly had 12 billion in sales last year and have roughly about 58,000 employees worldwide. So we are one of the biggest tire manufacturers in the world. And what is very important for us, that one of our key missions is to assure that we have a mobility which is safe, smart and sustainable. So this is already kind of bridging to the work we are doing here in the Live EVIA project. And we see it as our responsibility that we want to be one of the most progressive tire companies in terms of our environmental and social responsibilities. So based on that, we have plans of what we want to do at different stages of the tire production and the tire life cycle. So from material sourcing via operations to the use phase and the end of life. And obviously the Live EVIA projects fits very nice into our goals, which we have in the use phase, which ask for a clean and safe mobility we want to provide to our customers. So this is then definitely a field which we've been able to work on within the Live EVIA project. So with this short introduction, I then want to move on to the main agenda of my talk today. So we're going to have a small motivation and background at the beginning. Then I want to have a closer look at the physics of the tire torque and what they mean with respect to electromobility. Then I'm going to talk about the actual Live EVIA tire, which we developed here, which you can see at our booth behind us. And then, as usual, there will be a short summary at the end. So let's start. We had a work package B7 here, which was about the development of this holistic low noise tire for electric vehicle applications. And there we said we want to develop a tire which has a good holistic relationship between low exterior noise, that was our main target, but also other key performances. And Filippo already has mentioned this in this talk, that you cannot look at the noise on its own. You also need to consider other aspects if you talk about mobility topics. So in our case, this is of course the rolling resistance. This is very important for the energy efficiency of a vehicle, thus the contribution of the vehicle to the greenhouse gas emissions. And it is also very important for the user acceptance of electric vehicles, because the user wants to have a vehicle they can drive for a long time without having the need to recharge it. Then maybe the absolute most important performance we have to assure is, of course, the safety of our customers. So there needs to be a good wet and dry braking performance. There needs to be a good aquaplaning performance. And this is really the paramount requirement we have to have on the tire. This is the first requirement we have to fulfill. It needs to be safe in operation. Otherwise, it's basically not a good product. And then another important performance, of course, would also be wear. Again, wear is directly linked to the lifetime of a tire, and the customers want to have tires which last for a long time. They don't want to buy new tires every 2 months. And of course, a long tire lifetime also reduces the particle emissions and so also the waste. So also from a sustainability point, it is very important to have a tire which wears not so fast. So this is a little bit what we have to balance here with our low exterior noise. So this basically led us to the statement that the sustainability of a low noise tire is only given if we can assure that we have a holistic performance package, not only of noise, but also taking into consideration these other key performances. Now, something we like to talk about when we talk about tire performance are so-called target conflicts. Besides noise and rolling resistance and wear, there are other performances which we or the customers or society in general is interested in. So we have, for example, the values which we have on the tire label, which you might know about. These are basically forming the tip of the iceberg of our performances, which we need to consider. So like wet grip, rolling resistance, noise. For winter tires also ice and snow grip, for example. Then we have other requirements which are maybe more important for our customers. They are maybe important for us, or they are like in discussions to be on the next tire label as well. So it's all these different aspects we need to balance during the tire design. And what do we mean when we talk about target conflicts? I have 2 examples here. So one would be a target conflict between lateral aquaplaning, so the performance of the tire on wet roads in comparison to tire noise. And you might imagine for aquaplaning, it is very good if we have a tread pattern on the tire which has a lot of air, a lot of grooves, so that there's space for the water to go to. So this would give us a very good aquaplaning performance, but it would give us a very bad noise performance because the tread blocks which are formed there, they are basically our most fundamental noise sources we have. And on the other hand, or other side of the tire, or of the target conflict, we could go for a slick tire, so a tire without any tread profile. That would be very good for noise, but of course that would be horrible to drive on a wet road. Another example for rolling resistance versus noise would be that if we go for a tire which is rather thin in the area where it contacts the road, there's not much material which is deformed, so that means there's not so much energy loss. So that would be good for rolling resistance. But, I mean, most of you are acousticians, so you know that usually structures which are light, they are louder. So if we want to make a tire less noisy, we could just add mass, make it more heavy, then the vibrations will go down. But then we have more material which is deformed, so the rolling resistance would go up. So these are 2 examples for the target conflicts we have to deal with. And this brings me a little bit to the requirement book we set up at the beginning of the project. And I don't want to go into detail too much here. It's basically that we said that we're going to look at a standard summer tire for the European market. And we want to have excellent noise performance under conditions which are typical for electric vehicles. But we also said that for rolling resistance and wet grip, we should be of label values A or maybe B or A for the wet grip, so very good values in these performances. And we also said that we need to see that the tire as such should be more or less market competitive. Not to create something here which at the end of the day you would not be able to bring to the market. Now I want to have a short look at the actual physics of the tire road noise generation and what that means for possible noise mitigation measures. So the first point of or a physical point we need to look at here is the tire road contact, where we have an excitation of the tire in the footprint area either due to the tread blocks I've already mentioned or due to the road surface texture. And if we look at possible noise mitigation measures for this, then obviously we can look at a noise optimized tread profile, or we have the possibility to look at noise optimized roads for sure. Then if we look at the physical processes, what happens next is that we have a vibration propagation on the tire. So we have waves traveling from the contact patch around the tire. And for this, we could attenuate the propagation either by adding mass, as just pointed out in the previous slide, or we could increase the damping of the tire. For the mass, I've already said that's not good for the rolling resistance, and I guess it's easy to grasp that also adding damping would not be very good for the rolling resistance. So we could do something for noise here, but we are going into the area of a target conflict here. Finally, of course, what happens then is that the vibrations which are on the tire are radiated as noise into the air and then reach a receiver, whatever that may be. And basically, obviously, at this point, we would only have passive measures like absorption, damping, putting up barriers. And of course, for us as a tire manufacturer, this is a point where it's no longer our responsibility. We cannot do anything here. So looking at these basically three fields of mitigation measures, our target was, for obvious reasons, that we would focus on optimizing a tread profile, because this minimizes the target conflicts. And obviously the other thing we did in the EVIA approach was then the low noise roads. So as so often in acoustics or vibration problems, the closer to your source you tackle the problem, the more efficient it is, and this is exactly what we did here in the EVIA process. I want to have a quick look generally at a target conflict analysis, which was not done within this project, but which anyway provides quite some interesting information with respect to the potential we could achieve from in terms of noise reduction in our project. So what you see here is a comparison of a slick tire in the first row, so a tire without any tread profile, compared to 7 European summer tires, just regular market tires. And they are compared for different performances. We have in the first field, it's difficult to see from here, but I think it's, let's see, rolling resistance in the beginning. Then we have a couple of fields relating, or columns relating to noise performances. And then at the end, the final columns, they are related to wet grip and aquaplaning. And the greener a field is, the better the performances in relation to all tires tested. And the worst performance, obviously, then is a field which is very red. So looking at the first row, we see that the slick tire is very good for all noise performances. There's no tread, so there's not much tread block excitation. And we also see that it is very red for the wet grip performances. So as also previously pointed out, this tire is very bad.
Sorry, we have to change the microphone.
Okay.
For our colleague.
Excellent. Yeah.
Thank you. Sorry.
Is that better? Yeah. Good. So obviously for this tire, for the slick tire, good noise, but a very bit wet grip performance. So this is not a realistic solution. But what we can use this tire for is as a reference to see how are the other tires comparing to this best case for noise. And when you do that, you basically get that on the average of the 7 other tires compared to this slick tire for the noise performance is that the other tires are roughly between 1.5 to 2 dB worse than the slick tire. So the margin between a regular tire on the market, or an average regular tire on the market, and this best case scenario is just 1.5 dB. So you see we are already getting a little bit away from this 4 dB, which we heard coming from the European Commission earlier today. So yeah, this is our assessment. You maybe can come to other conclusions, but basically this is what kind of set the baseline for us, what was achievable within this project. Then you can also look at the data a little bit different. You have this spider graph here where you see the performance in the different different tire performances which were measured. 0 value basically means it was the worst tire in this study. 10 means it was the best tire in the study. And the focus here is on the 4 tires which had the best wet grip performance, so very good in safety. So you see that in this quadrant which is marked green. And then in the quadrant which is marked red, you see that for these tires, actually the noise performance was not very good. So again, pointing out that there's a very clear target conflict here, which you somehow need to solve. We also did an internal study at Continental where we compared the performance of a slick tire with one which has circumferential grooves. And adding these circumferential grooves to the tire is basically the minimum requirement you need to fulfill to get a wet grip performance which is acceptable and an aquaplaning performance which is acceptable. And you see by just adding these grooves, we already go up by 1.3 dB in noise. So just by having to account for safe driving on wet roads, we already lose a lot of the potential we have for noise optimization. So to sum this up for the project, as a starting point, we took our EcoContact 6 product, which is a regular summer tire, which has quite a good noise performance, and it has fuel efficiency and wet label classes R, so it's a very economical and ecological tire. So it's not that we started with something here which would be easy to improve in noise. And then our strategy was to use existing validated technologies in a smart and novel way. So use bits and pieces, entire technology which already existed, and then put them together in a new way. And the focus, as I said, was mainly on optimizing the tread, because this gives us the best possibility to optimize or control the target conflicts, also in combination with that the other objective of the project obviously was to optimize the road surface as well. And this is directly where we have the contact between these two, let's say, possible mitigation measures. And finally, our assessment that was taking into consideration, especially our wet grip requirements, that we would be somewhere between 0.5 dB and 1.5 dB in reduction with this tire as a target value, depending a little bit on operating conditions and so on. So I want to quickly have a look at the role of tire torque, because this is something you need to consider for electric vehicles. So for electric vehicles, when you compare them to internal combustion engine vehicles, you have the situation that you have a considerably wider RPM range at which you have maximum torque available at the tires. So, I mean, every Nissan Leaf can easily outperform a Ferrari from a red traffic light, just because the torque is instantaneously available. And this is something we need to consider because it is important for the noise generation. That, for example, was also shown in the Live EVR project by our colleagues in France, who did a study here where you see these solid lines is basically the noise measured for an electric vehicle at constant speed. And then the dots you see above is the noise leveled at the same speeds but under accelerating conditions. So you see that basically you have a parallel shift of this speed-dependent noise level. So you get roughly 4 to 5 or even more dB of noise increase by applying torque compared to a constant speed. And the reason for that is that without torque, our main excitation mechanism coming from the tread pattern is the radial impact of the tread blocks. So we have a radial excitation of the tire body by these impacts. And with torque, we additionally get so-called stick-slip mechanisms. So within the contact zone between the tire and the road, the tread block will stick to the road, and then due to the rotation, it will at some point, the shear forces just get too large, and it will be released again, leading to a vibrational excitation of the tire body in tangential directions. And also, when the blocks finally leave the footprint again, we have this snap-out effect that all of a sudden they are released and they start to vibrate. So these are additional noise generation mechanisms we have to deal with for electric vehicles, which are not so important for most classical vehicle applications. Then some know-how we generated during the project was quite interesting. What we saw is that this torque effect actually influences the ranking between different tires. So what you can do is you can measure tires, for example, on the indoor drum, as we did here, and then you can look at the noise levels for different tires at different speeds on a constant rolling, and then you can say tire A is better than tire B, and tire C is worse than tire B, and so on. And we did that with our reference tires and some tires from the test vehicles from the colleagues in France. And what we saw is that this ranking is pretty unique between the tires, or pretty constant between the tires for different driving speeds. So here shown for 50 and 80 kph. But this behavior all of a sudden changes when you move over to driving with torque. So this is the last column we see here. So for example, compared to the reference, if we look at the second row, this test vehicle 1, we see that it is roughly 1.8 and 1.6 dB worse than the reference at constant driving. But if we then move to the last column where we show the data for driving under torque, all of a sudden the same tire is 1.7 dB better than the reference. So we have a clear change of ranking here. And we see similar effects with the other tires here. So it's definitely that this is something which we need to consider. We cannot just assume that the tire is good under constant rolling and then it will also be good under these new torque conditions. This study is basically showing the same thing. This time it was done on the test track. We have on the x-axis here, we have different acceleration levels with the value at 0 being at constant driving, and then on the y-axis we have our noise level again. And I don't want to go too much into the details, but you see these interpolation lines here connecting the measurements, which are the single dots. And you see that the slope of these lines is quite different. So if you have, for example, this lowest measurement value at constant speed, which then has a very steep slope, and then at an acceleration of 2 meters per square second, all of a sudden this tire is a lot, or is not the noisiest one, but it's for sure not the best tire anymore. Then what we also noticed in the project is that actually also the road surface plays a role on this behavior. So this were then measurements which were done at the test track in Nantes, where we looked at 6 prototype tires we had within the project, 2 different test vehicles. And we see here 2 different cars, electric vehicle in orange and an internal combustion engine vehicle in black. The first column is always the surface without crump rubber, and the second surface is the one with crump rubber. I think Julien will talk a little bit about that in his presentation later, so I'll spare you the detail. But basically what we see here for constant speed, the first column for each color is always the highest. So that means always we get higher values for the surface without crump rubber compared to the one with crump rubber. So the crump rubber surface is always better, apart from one outlier we have here. If we go over to acceleration, then all of a sudden we have 1/3 of the cases where this relation shifts around. So 1/3 of the cases, all of a sudden the noise levels are higher on the PCER surface, so the surface with crump rubber. And this is, I don't want to go into detail here, but this is basically coming that the noise increase on this surface seems to be always higher than the noise increase we are seeing on the surface without crump rubber. Still, we can, even with this effect, we can still state that probably the most promising tire road combinations for these prototypes we tested was still the surface with crump rubber. But it's at least not as clear the picture when you look under acceleration as it was looking at constant speed. Looking a little bit more at the tire optimization, what we also did with these prototypes was compare different solutions for our tread pattern. And we compared here 2 different tread patterns which had a different ratio of the shear stiffness and radial stiffness. So one pattern where basically this ratio was higher, and another pattern where this ratio was lower. And what we see here is basically the delta of these 2 tires, so the difference compared to the performance of the reference, again for free rolling and acceleration. And we see for the first tire, so the one having a higher ratio of shear stiffness to radial stiffness, the tire gets louder under free rolling, but it gets better under acceleration. And it's then vice versa for the second pattern, where the shear stiffness relation is the opposite way around. So this was quite interesting know-how for us, which we were able to get from these measurements done here during the project. So what does that all mean for our live EVIA tire development? Basically, a quick look at what we did here. We had 3 development loops, as we call it in the tire industry. So basically, we had 3 cycles of where we were doing investigations, then coming to some conclusions, building tires either physically or only virtually in this second development loop, where we just stick to simulations. In all 3 cycles, a lot of the development was basically done by numerical methods. This is just the standard as it is done these days in the tire industry. You want to avoid costly tire building and testing. But of course, testing is very important. So we had basically one testing loop for the physical tires, which were built based on loop 1. Where the tires were both tested at our indoor facilities, and they were also tested at the test site in Nantes on the prototype surfaces we had there. And then they were also tested actually after the implementation of the optimized road surface here in Florence as well. And then for the final tires coming from loop 3, again, we did indoor and outdoor tests in our own facilities. And then just last Tuesday, we also got some results here from Florence. I have not really seen the figures yet, so the results I will present on the next slide. They are just based on our own internal testing, but I'm pretty confident that what we measured here this week will confirm this. So, coming to probably the most important slide, what did we achieve in the end? So I want to start with the target conflict analysis, because on one of the first slides we said we need a holistic tire, which performs well not only in noise but also for other key performances. So we have here in orange the reference, which of course for all performances we are looking at here is at 100%. That's why it's the reference. And then we depict for the performances how much better in percentage the new EVIA tire is compared to that. And we see for constant speed pass by, it's a little bit better than the reference. We see under acceleration, it's a lot better than the reference tire. If you combine that, as some of the legislation asks for tire certification, then we still have quite a large improvement compared to the reference. And then also very important, coming to the non-noise related performances for rolling resistance and wet grip, we are basically exactly at the same level as the reference, so we could keep the performance there. Being slight under 100% for wet grip is basically the value there is within the measurement uncertainty, so we should not worry too much about that. And handling and wear performance were only simulated. This is why they are marked with an asterisk here, with handling basically being on also roughly the same level as the reference, and the wear performance we actually estimated to being better than the reference. So even though we did not really optimize the tire for that, that was quite a nice outcome, that we could not only keep the performance but even potentially improve it. So of course we are all acousticians, and these weird noise values here in percentages don't mean much to us. So let's come to the point here. So this was already very good, but if we look at pass-by noise performance as measured on our test track, we were basically 0.3 dB better at constant speed at 50 kph. Under acceleration, we got 1 dB, which I think is a very good result. And then combining this, we end up at a reduction of 0.8 dB, which is well within the target I just laid out a couple of slides earlier, which was between 0.5 and 1.5 dB. So we're somewhere there in the middle of the range where we want to be. So obviously that is very nice. So of course now the next question is, okay, how does the tire actually look like? And for that, I would like to invite you to just go to our booth and have a look yourself, because being able to see the tire there in 3D and being able to touch it is probably better than any picture on my slides here could present it. So, and that I'm maybe already a little bit over the time, but I maybe have 1 more minute for a quick summary. So within the project, we used validated existing technologies in a new, smart and novel way to create a holistic noise-optimized tire for electric vehicle applications. Compared to the reference tire, which was already on a good noise performance level, we were able to get a reduction of up to 1 dB in the relevant pass-by measurements. We could maintain the noise, we could perform keep the performance for the other important tire performances, such as rolling resistance and wear, for example. So we really have a holistic tire here. And very important for us is also that the project created valuable insight into the interaction of vehicles, test tracks, road surfaces, and so on, especially under this new field of looking a little bit closer under driving under torque conditions. And yeah, that brings me to the end, and I would like to thank you all for your attention and all our project partners for the nice collaboration. Thank you.
Thanks a lot, Carsten, for your very, very interesting presentation. And now I ask Julien to come here. The next contribution is tire pavement coupling study and prototype implementation, and it's presented by Julien Chesbron, who is a researcher at Université Gustave Eiffel, dealing with mechanical and acoustic engineer. Please.
May I sit there?
Yes.
It's better to see. Okay, hi everybody. Thank you, Rafaela, for introduction. Maybe it's better like this. Yes, so I'm going to speak about our activities within this project, LIFEVIA, which deals with tire pavement coupling study and the prototype implementation in Nantes, actually. So this presentation was prepared by me and my colleague, Marie-Agnès Palas, who is here. And yes, we are from UMRAE, which is a joint research unit in environmental acoustics at Université Gustave Eiffel. This lab is based in Lyon, Nantes, and Strasbourg. And within this project, the sites from Nantes and Lyon were involved. You have heard about the context this morning already, but there is an exponential increase of electric vehicle fleet within Europe already. If you look at the figures on the WhatsApp for the European from European I think it's AirTro, maybe not. But there is an observatory for the increase of electric vehicle within Europe, and you have this figure for EU 27, in 2021, and there is up to 3.9 of electric vehicles and in European in this year, and it represents 18% of new registrations. Depending on projection scenarios, the electric fleet could be up to 50 to 30% of the market in 2030. As it has been explained, it's an evidence that electric motors are quieter than internal combustion engines. And then for electric vehicles, tire round noise will become the prominent source of noise. Even in urban area, that means up to 20 kph. Yeah, so from the study of Continental at the beginning of the project, future market, there is tendency that future market of electric vehicle tires will stay within standard tire dimensions. while EV tires have some EV vehicles, EV tires, sorry, have some must require some specificities from EV vehicle, electric vehicles, sorry, in comparison with internal combustion engine vehicles, such as vehicle range optimization, higher torque, and higher curb weight as well. So within the LIFE EVIA project, we were in charge of the tire pavement coupling study, action B2. It's an implementation action, and it's subdivided into 4 sub-actions. So action B21, dealing with the acoustical characterization of existing electric vehicles. Sub-action B22, which is the construction of the prototype test track in Nantes. Action B23, which deals with the characterization of these prototypes in terms of acoustics and friction. And finally, sub-action B24, which deals with the selection of optimized tires for electric vehicles. I will not go through all the details, but you can go on the LIFE EVIA website and download the deliverable, which was published in May this year. So I will start. In the following, I will describe the main results of each sub-action. So let's start with action B21, acoustical characterization of electric vehicles. So what we did is a measurement campaign, several measurement campaigns on our reference test track at Université Gustave Eiffel in Nantes. So we decided to test 3 impervious road surfaces. You can see here road surface N, which is ISO test track like test surface. Dense asphalt concrete 10, E1, and SMA 10, E3. And we also tested 3 absorbing road surfaces, namely A, which is a porous asphalt, M2, which is a very thin asphalt, concrete 6, and M3, which is VTAC 4. For all these surfaces, we have the road surface characteristics, which will mainly influence noise, which are the characteristics of the road texture, mean profile depth, and the texture spectra, and also for the absorbing road surface, we have the sound absorption properties. So you can see here on these graphs the difference in properties in terms of texture and absorption. Then we have tested noise pass-by noise levels with 2 type of measurements: standards control pass-by measurements on all road surfaces, the 6 road surfaces, and microphone array measurements only on the N road surface, which is the ISO-like road surface. Pass-by conditions, we have tested different pass-by conditions, constant speed, from 20 to 110 kph. Full acceleration conditions, starting from 0 to 50 or 90 kph, depending on the vehicle, and regenerative deceleration from 40 to 50 kph, so 40 to 90 kph initial speed, sorry. So you can see here on the test track on the left, there is pointer on it. Yeah. On the left, you have the control pass-by test. On the right, you have the microphone array. You can see the microphone array at the roadside. We tested 6 recent electric vehicles, which were representative of the electric vehicle fleet at the beginning of the project, which means 2019. 5 passenger cars and 1 light commercial vehicle. So you have here the different vehicle models, and different EV segments were involved. 2 super mini, 2 small family cars, 1 large family, and 1 light commercial. The passenger cars were fitted with their original equipment tires. You can see here the different tread pattern and size of the tires, and also the make of the tires. And only for the Kangoo, electric Kangoo, the Kangoo ZE, this vehicle was, which is a light commercial vehicle, this vehicle was fitted with new tires for comparison with internal combustion engine vehicle, which is strictly the same, the Kangoo diesel. You can see here a difference between the two Kangoos, so the electric one and the internal combustion engine one at constant speed. So what we did is that we separated the engine and ring noise. I'm too close. Yes. Okay. Is it okay?
Yes.
Like this?
Yes, if you are too.
Okay. It's okay for the audience? Do you hear me? No? Like this? So, what should I do? No?
Problem for the people is
Connected.
connected with.
Ah.
Okay.
No,
Okay.
it's
Go on.
okay.
Go on.
It's okay.
Okay.
Go on.
I can speak. I remove and speak
Okay.
low.
No, okay, it's okay.
Okay, so we separated the engine and the rain noise component for the Kangoo diesel, and then we, as you can observe, you have a crossover speed of the two components, around 40 kph for test section N. Sorry, and if you look at the component for the Kangoo diesel, you can see. That you look at the ring noise component for the Kangoo diesel, you can see that it is very close to the points of measured points for the Kangoo electric Kangoo, so KZE, which means that tire rod noise dominates the noise emission of electric vehicle at constant speeds. It's not a big surprise, but it has been assessed, scientifically speaking, with these measurements. And on the right, you can see the microphone array noise levels. So the array is at a distance of 2.7 meters at the roadside. And as you can see, you have for the KD, so the internal combustion engine vehicle, you have higher noise levels at the front where the motor is located than at the back. And for the Kangoo ZE, you have a balance, which is due to the fact that tire rod noise is dominating. If you look at the control pass-by noise levels at constant speed for the 6 vehicles now, you can see that you have a very similar classification of the road surfaces for the 6 electric vehicles. And the tendency is that the road surface with low macro texture, which are, for instance, M3 or N, and or absorption, like A, M2 and M3, are the quietest road surfaces. And there is a stake in noise levels difference between, let's say, roughly 5 and 8 dBA, depending on the electric vehicle model. If now you look at the CPB and microphone array results at constant speed for 50 kph for test section N, you can see that you have a difference of about 3.6 dBA between the quietest and the loudest electric vehicle. And there is no clear relationship between the electric vehicle model in terms of segment and the noise level classification. As you can see, for the loudest vehicle, which in this case was a Renault Zoe and Nissan Leaf, if you look at the microphone array results, so that's these vehicles, you can see that at the back of the vehicle there is the highest noise level, while tire roll noise is dominating, it's exactly the same tires at the front and the back of the vehicle. So there is also an influence of the vehicle shape itself. If we switch to the CPB and microphone array results in full acceleration conditions, you can see that the classification of road surfaces is pretty similar, but there is an exception for the ISO test track, and which becomes one of the noisiest road surface, especially at low speeds. This increase in noise levels is in the order of 5 dBA for road surface N compared to constant speed. So there is this tendency to have an increase in noise level of 5 dBA between constant speed and acceleration, as well as was already explained by Carson before. And there is, of course, torque effect, which was described by Carson in the previous presentation, but also probably an effect of electric motor noise, which is more important when you are in full acceleration for electric vehicles. So you clearly see on this example with the microphone array, you can clearly see the difference between constant speeds for the Renault Zoe and the full acceleration. And this vehicle is a front-wheel driven vehicle, so you see a clear increase. So that's it for the action B21. For action B22, this action is dealing with a prototype construction. So based on B1 action, which was managed by University of Reggio Calabria, we have followed the recommendation for the mix of the prototype, designing a low noise asphalt for electric vehicle, and we have implemented two different mixes of very thin asphalt concrete. Maximum aggregate size is 6 millimeter, and one of the mix has 2% of chrome rubber. You can see here the result of some picture of the prototype construction, which was performed in September 2020, and the test site is still the Université Gustave Eiffel reference test track in Nantes. So the result is about 57 meter prototypes, one with chrome rubber, namely PCR, and one without chrome rubber P. And for the following of the presentation, we will consider the surface E1 as a reference, so the dense asphalt concrete 10. We perform within action B23 prototype characterization with a lot of measurements in terms of noise, but also in terms of surface properties influencing tire roll noise, 3D texture, mechanical impedance, sun absorption, and some friction measurements. You can see here the results for the surface texture. You can see that P and PCR, the prototypes, they have a low mean profile depth, and they have quite low texture levels. So this is favorable in principle for noise reduction. Regarding absorption, we did not measure very big absorption, only 0.26 or 0.20 absorption around 2,500 Hertz. And the dynamic stiffness was in the order of classical dense asphalt concrete, if you look at the graph on the right. In terms of noise, of control pass by noise, at constant speed, you can see that we have tested different vehicles. Here you have the results for the Renault Zoe and the Renault Kangoo ZV. you can see that we observe a noise reduction in the order of minus 0.5 dBA for prototype P and minus 4 dBA for PCR. And as a whole, so the reduction is around 4 dBA quieter than the reference dense asphalt concreting. So you can see that it's so you have to look at the histogram in black. The bars in black are the prototype. They have a good performance as a whole in terms of noise reduction. In full acceleration, we have some different results depending on the vehicles, as you can see, and depending on the prototype as well. But we observe the tendency is that we also have low noise surfaces. We also perform close proximity noise measurements, so CPX, according to the ISO standard. One set of measurement was performed by with our equipment at UNIFL, and the other measurements were performed by iPool with a SRTT tire, which follows the ISO standard as well. And as you can see in the table, prototype P and PCR are quieter than the reference E1. And for P and PCR, this prototype test section meets the core criterion of the green public procurement for low noise pavement. So that's LCPX less than 90 dBA with the SRTT tire. And for PCR test section, we are close to the most stringent comprehensive criterion, which is LCPX, CPX noise level less than 87 dBA. So it fulfills requirement of the objectives of the project, so that's a very good result. My last part of my presentation deals with action B to 4, which deals with the selection of optimized electric vehicle tires. So technical demonstrators of tires were delivered by Continental to us for testing on the two prototype test sections, so P and PCR. And the main variation was on the tire tread pattern, not on the structure of the tires. The other construction of compounds were similar to the reference tire provided by Continental. So we performed constant speed and acceleration pass-by noise measurements on the different tire versions, and also CPX measurements with different tire versions. So you can see here two pass-by conditions according to UNEC procedure, so constant speed at 50 kph and full acceleration with 50 kph when facing the microphone. And we have tested 6 different tire versions with 2 different vehicles, electric one and internal combustion engine one. So the results were already presented by Carson, but it was another way to present the results. But the conclusions are the same, of course. If you look roughly at noise levels, you can see that on average, PCR with chrome rubber is quieter than P without chrome rubber at constant speed. And when you consider acceleration, you can see that there is an increase of noise of about 5 dB. And if you look at the differences between the different tire version and the reference, so V1 is the reference, and then you have V2 to V6. You can see that most of the tire version reduced noise at constant speed, but when you consider acceleration, you can have some inversion, some increase of noise reduction, but also some inversion. Some tire version can become louder than the reference. For instance, if you look at V6, sorry. And finally, for the CPX noise levels at constant speed, you can see in this case we have compared the prototype test session with all the different test track, test sections, sorry, on the test track. You can see that again P and PCR and P are among the quietest pavements, and PCR is quieter than P, but the difference can depend also on the tire version. Yes, that's it. So the PCR is up to 1.1 dBA quieter than P, depends on the tire version, and also it's important to see that the noise reduction with tire relative to tire is up to 0.6 dBA on PCR and -1 dBA on P for V4. For the conclusion, so looking at the road surface influence on control pass-by noise levels, there is a noise reduction. There is a range, sorry, between roughly between 5 and 8 dBA at constant speed, at 50 kph. Tire road noise, of course, dominates electric vehicle noise at constant speed. And road surface with low macro texture and absorption are among the quietest. In full acceleration, there is an increase of electric motor and torque effect on the tire, which lead to roughly an increase of 5 dBA of noise. And we have implemented two Velicin asphalt concrete 06 as a prototype test station, so P and PCR. PCR contains chrome rubber. Regarding the noise reduction, in terms of CPB noise levels at 50 kph, P and PCR are 3.9 to 4.7 dBA quieter than the dense asphalt concrete 10. And P and PCR test section meets the core criterion of the GPP for low noise pavement. And finally, regarding electric vehicle tire optimization, further noise reduction versus a reference tire, the reduction is at best in the order of 1 dBA at constant speed and 1.5 dBA in full acceleration, which I mean is the same conclusion for Carson. Okay, I would like to thank you for your attention and, of course, all partners contributing to this action.
Thank you, Julien. And now it's time to see the asphalt in the pilot area. And I leave the floor to Arnaldo Melloni, who is our project manager, responsible for the unit of public hygiene, environment and durable livability of the municipality of Florence. And the title of his contribution is the Life Via project in Florence and replication strategy. That is, of course, one of the main results of a co-funded project to be replicated in other places. So Arnaldo, please.
Thank you. So a very brief presentation and with also a video, so you can prepare the popcorn and what you want, so whatever. It's a video with a general presentation of the project and with some idea of our administration regarding the use of this project and how to continue to work in the direction that this project show us. Okay. So, first of all, I'd like to say that pilot case is very important for us. It's very important for the project because with the pilot case we create the condition to test a technical idea, and if it works, we can reply a good practice. Reply a good practice in our cities, of course, but also share our experience with our cities. Florence is a member of one of the most important association of municipalities association in Europe, Eurocities, and we meet other cities in the occasion of the Environment Forum of Eurocities, and there is our favorable places where it's possible to share idea, to share project, to share what we do in our cities. And this project is one of the things that we share with other colleagues. So we choose Paesiello Street as a pilot area because, first of all, Paesiello Street was in our city program of general renew the asphalt in all the city, and the characteristics of Paesiello Street are fit with the project. In fact, we have a two-way road without significant curves, high density population in the area, busy road due to the traffic toward the city center. It's close to public offices, close to the most relevant park in Florence, close to one of the most important interventions of urban requalification with the new buildings, primary school and fashion school. Here you can see a summary of the construction-related procedures. And as you see, we start in September 2020 with the first technical documents. When we had the new mixture, as you say in the previous presentation by Filippo, we did the tender conduction in March 2021 and the implementation in July 2021. Some pictures show the works in the last July. In this picture you can see the road when the works will finish, and here now I can show you the video, and after I'll say some few words regarding how we continue with the work in this project. So we can start with the video. Thank you.
Il Comune di Firenze è capofila del progetto eLife Via, che punta a realizzare, a mettere in posa un nuovo asfalto, un asfalto fonoassorbente per ridurre l'inquinamento acustico all'interno della nostra città. Lo abbiamo già realizzato in una strada molto trafficata del quartiere 1 di Firenze, via Paesiello, e devo dire che questa sperimentazione è già stata accolta con grande favore dalla cittadinanza del quartiere. Il tema infatti dell'inquinamento Un tema importante, l'Europa ci spinge a lavorare su questo ambito proprio perché è causa di grandissime malattie e fino ad oggi forse anche un po' sottovalutato come fenomeno. Per questo abbiamo deciso di candidarci con questa progettualità con tutta una serie di partner, tra cui la direzione Mobilità, e lo stiamo seguendo con l'assessore Giorgetti, con cui pure individueremo nuove vie all'interno del territorio comunale dove sperimentare questo nuovo asfalto fonoassorbente per ridurre l'inquinamento acustico e poi per sensibilizzare anche la cittadinanza su questo tema e sul tema anche della mobilità elettrica e sostenibile, su cui pure la nostra città con tante iniziative e progettualità sta andando avanti.
La direzione ambiente del Comune di Firenze ha una lunga storia di partecipazione a progetti europei e di vittorie nei progetti europei che sono stati di conseguenza finanziati. Sono progetti in campo ambientale che riguardano vari aspetti dell'ambiente della nostra città. In modo particolare in questo ci concentriamo su due aspetti, sull'aspetto dell'inquinamento acustico e sull'aspetto dell'inquinamento atmosferico. Infatti qui ci troviamo appunto in via Paesiello, dove è stato steso un asfalto sperimentale e l'idea è quella di riuscire a combinare per la mobilità elettrica i migliori pneumatici con il migliore asfalto, con lo scopo di abbassare e ridurre l'inquinamento acustico e l'inquinamento atmosferico.
Il progetto Life e Via ha come obiettivo, uno degli obiettivi principali, quello di studiare e ricercare un'ottimizzazione di pneumatici e asfalti per la risoluzione del problema del rumore nelle città del futuro, che saranno città dove la mobilità si sposterà sempre di più verso l'elettrico. Infatti i dati della International Energy Agency ci dicono che entro il 2030 oltre la metà dei veicoli venduti saranno veicoli elettrici. Inoltre il problema del rumore è ancora uno dei principali problemi ambientali nelle nostre città. Basti pensare che in Europa oltre 125 milioni di cittadini sono tuttora esposti a livelli di rumore che vengono considerati come dannosi per la salute.
L'idea è quella di utilizzare questo progetto come leva per comunicare ai cittadini l'importanza dell'utilizzo dei mezzi elettrici in chiave appunto di riduzione dell'inquinamento acustico e atmosferico e di miglioramento complessivo dell'ambiente in ambito urbano.
Okay, as I said before, some few words regarding the replication. The first thing that I like to share with you is that when we spoke with the people who lives in Paesiello Street, we were surprised because all the inhabitants all the inhabitants was very happy of our intervention. So they asked us to reply the intervention in all the entire Paesiello Street. So this is the first. Our first activity of replication of the intervention. But according to the satisfactory, good results of the post-operant test and measures, we have been identified for the replication two important streets in our city, Via Bolognese and Via Senese, where in these days we are approving the project, and in the next 2 months we finish the job. So we will have the first important results of this project. As I said before, we work in this project. We organize the participation in this project because we believe that it's important to reply what the good results of the activities. And we have also two other situations where it's possible to have a replication of the project, and the life via asphalt was proposed in the noise action plan of the municipality of Inzago, that they identified our solution as a remediation action for critical areas. So, and then the other action, the other situation is in the noise action plan of Livorno, that not yet realized, but is in the noise action plan of Livorno we have our project identified as a remediation action for critical area. So thank you again, and I think that we have now another presentation, and I hope to thank you.
Thank you, Arnaldo. I think that we can be happy of the results, and that people appreciated the results and asked to continue the activity of our city. And then I ask Francesco Bianco to come here. Francesco is a member of iPool company. He's specialized in noise and vibration measurements from transport infrastructures and the statistical data analysis, and he's going to present us a contribution regarding the evaluation of payment characteristics, electric vehicles, noise emission, and guideline issuing. So Francesco, please, you can start. This is to change the slides.
Okay, good morning to all of you. For the last presentation, I have a very great deal of data, but I avoided formulas. I will try to be light and to go as fast as I can. So if you do not understand something, it's my fault. So what I'm talking about is the measurement campaign we took in Via Paisiello. We measured different pavements properties from the acoustic point of view. So I will introduce to you the techniques we used and the results we had, and how we used those results to obtain something about how we can model electrical vehicles and the new mobility that could happen in the near future. So, well, noise sources, engine, blah blah. My partners in the project have talked extensively about this, so I will skip everything. So the techniques we used. The first one I present to you is the CPX measurement. So a couple of microphones nearby the wheel. The point is that this is a measurement that is of the near field. So what is generated by the interaction between the wheel and the road. It is a measurement that can be taken along a surface. So it's a sort of diffuse measurement. It can give you information about the whole functioning and the whole behavior of the road from an acoustic point of view. So this is an example of what we can get from this measurement. So a lac value for sections of about 20 meters. There are also limits that have been cited before about what we expect the CPX values are at the beginning of a pavement, and the durability we would want within 5 years. You can download this for free, obviously, from the European Community sites. Another kind of measurement is the CPB. This is a point measurement that is taken nearby the road. What does it mean is that you pass at a certain distance from a microphone, you measure the speed of the vehicle, and you control in some way what is happening. So you choose a specific vehicle and you measure how loud it is. This is an example of the elaboration we take. So we acquire the raw data, the pressure value, we integrate it, we find the passage, we recognize which passage can be used and which one must be excluded. And so we obtain a regression line that is logarithmic in speed, and it happens also with CPX values and the spectral value. But the point is that this is a point-like measurement. So I have a microphone fixed in one position. So my measurement is obviously influenced by what is present in the area, especially from the pavement point of view. While the CPX is a continuous measurement as to respects. But in this case, I'm also evaluating part of the propagation and part of the noise that the whole vehicle generates. While in the CPX case, I'm measuring only what happens nearby the wheel. So these are complementary techniques, more or less. Another kind of measurement is the acoustical absorption with the extended surface. This is an impulse response kind of measurement. I won't delve into the details, but the point is that we can measure what happens between 250 Hertz to 4 kilohertz. It is not well suited for reflective pavements for signal to noise ratio reasons, but it works very well, and it is almost specific for absorptive pavements, so open and porous ones. Another technique we employed that is more suited to the test site is the impedance tube on site. This is a tube that has microphones in it, and there is a speaker in the upper part that, as you can see, must be held together with duct tape. This is a specific requirement of the ISO standard. So this is the result we have. The tube has a more limited frequency range that depends on its geometry. And it is very well suited for very reflective pavements, but it cannot be used for absorptive ones. So above 0.15 of absorption, the ISO standard tells you it must not be used. So on the contrary, the extended surface is the technique you can use for absorptive pavements. This is the test site. You have already seen it. This is the measurement scheme that we adopted. So with the techniques you saw before, so the extended surface and the impedance tube, and then we measured also other parameters. We'll talk about them later. We tried to measure both the wheel track and the center lane to see if there was any difference and how they evolved. We measured along the road in 3 different sections. One of them is a section in which we measured also the CPB. It differs for the 2 pavements. This is an example for the first measuring session in which were present also UGA. They measured the 3D texture in there. So the road was actually closed because having cars run over us wasn't a good idea. And it takes some time to perform those measurements. I must say this. I'm actually recovering from sleep deprivation because we have finished the last measurement session, as Carsten knows, just this night. But we are happy because it is finished now. This is the squad of the first measurement session. I wanted to show you those brave operators of the road. This is another schematic of the test site, in which you can see that the first part is the pavement that has crumb rubber in it. The second one is the one without, and a sort of indication of the measuring points. So these are the measurement sessions we took. We measured the road for a year, essentially. I cannot show you every data because we haven't finished all the analysis, but this is an example of a CPX value. The red part on the left is the old pavement. So it's above the scale we used for representing the other two. So there is a significant increase in decrease in noise production there. These are the CPX values for the pavement for the first two sessions and for the other two. But this is more interesting. This is the whole evolution of the noise behavior. So the P pavement has a strange behavior, but it is within the measuring uncertainties, while the PCR is behaving more as what we expected. So it started very, very low, and it seems to beginning to reach a sort of plateau in behavior, and it is still very good. We are below 90 dBs, so below the GPP limit at the beginning of the pavement. So not bad. Compliments to who laid that and who made the project. So these are values for the Kuhn tube. We can provide different kind of values, an aggregated value, the LRI. It's more immediate, but what I will show you next are actually the values of absorption in frequency. So the graph that is on the right, but you will see it now. This is the first measuring session, the comparison between the PCR and the PE. You can see that the crumb rubber pavement is slightly more absorptive. We are talking about reflecting surfaces anyway, but there is a slight difference that the tube can appreciate. This is the February. The measurements were not as good, but we can see the same difference. And then this is the July session, in which we can see that they are almost the same. So there was an evolution in this absorption coefficient. This is the comparison for the PCR in the 3 sessions that I showed you before. As I told you, we actually have measured the fourth one, but I hadn't had the time to elaborate them. And this is the P pavement. This is a comparison between the extended surface. I won't show you every result in this case, but we can see that it is similar, quite similar. We are still talking about low emission pavement, low absorption pavement for the two. Obviously, the tube cannot reach 5,000 Hertz, so the graph stops before. And next, I'm telling you something about what we did to achieve the last part. So the calculation of the parameters that we put in the Knossos model, and how we achieved it, and what we can do with them. So talking about the passages, we actually calculated the cell values with an integration. We are showing here a couple of techniques, but the results we will see afterwards are based on the calculation on the left side, so the 10 dB method. I don't know how long I have. Okay, so the difference. Okay, the difference is here is that. In the left, we take the maximum of the passage, and we find the values on the left and right side that are 10 decibels below. In the other case, we measure the speed of the passage, and we integrate the passage over 15 meters. So they are slightly different, but we did it to see which behaved better, because the problem is that those data that we took were taken in an urban environment. These are not data for ISO standard. So we wanted to see if there was some improvements with a technique or the other. That's what I saw. I told you before. We can see that in this example there is a slight difference between the levels, the integrated levels, but not too great. The reason for which we actually tried to use this sort of distance method is that in the test site we have not only buildings everywhere, but also bumpers on the road. Especially there was a problem in the analysis for the PCR pavement, because the bumper, we have the crosswalking above them. So the bumper was nearby the measuring position. So data were not as good as the other pavement. So we tried this also to have a better comparison between the two pavements, because we are comparing potatoes to oranges in the other case. And that is the result of the cell analysis. Also in this case we have a regression that is a function of the speed, and we can see that it follows also a logarithmic relation, as we should expect. We also evaluated how good the fit, the logarithmic fit speed was as a function of the frequency. Is in this very small graph in the right upper part. There is a dashed line that tells us where there is a very good fit for the speed relation and where there is not. So in the main part of the emission, above 300 Hertz, the fit, 400 Hertz, the fit is good, so the behavior is what we expected from a physical point of view. And then the next part. So those data were used to create the database for the Knossos model, to create a new category in the model. The Knossos model is somehow complex, but mainly it has parameters that are function of the type of vehicle. And there are let's say four classes of vehicles, and it is possible to add others. So electrical vehicles could be the next class. So the logic of this is that we took data from electrical vehicles, we rented electrical cars, and we made them pass over the pavements. We measured what they emitted, and we created this database for electrical vehicles, but also for the pavements, as I will show you in a short while. At the end, we used this model to have a sort of prediction of the noise emission of the road. So this is the main formula that we have to understand. This formula has a dependence on the vehicle speed, this log Vm over Vref. Vm is the vehicle speed, essentially. But this formula depends also on a couple of parameters, A and B, that are both dependent on frequency and on vehicle class. I don't remember if the I stands for the vehicle and the M subscript for the frequency, but it's one or the other. But this formula is the emission, the vehicle emission, that depends on all those parameters. So it's quite complex to have all the data you need to actually calculate those parameters. This is the whole data set we had for expressed as a function of the frequency, the frequency of the speed at the frequency band of 500 Hertz, because we had to extrapolate the behavior for frequency bands. So the graphs I'm showing you are plotted like this for this reason. We can also see that we have a bunch of vehicles that are behaving essentially the same way, and there is another that is louder, much louder than the others, for 500 Hertz. At 1 kilohertz, there is no such a distinction. This is the center of the emission, sort of. So this is what you hear better than 500 Hertz. And this is at 2 kilohertz, in which we see that there is also this kind of bad behaving vehicle. Then this is an explanation of the calculation techniques. After we did all the fits you saw just before here, we can calculate the predicted values, and we can use them to extrapolate the parameters. And then we can use the parameters to produce with the Knossos model the cell values that were expected as a sort of a control, of an analytical control, but to see if it's all going well, it's better to put the numbers into the machine and to see if it spits the correct results back. And it did, fortunately. That's why I'm here now telling you about this. And these are the results for the parameters. I won't delve too much in the details. Next, we tried to understand what the contribution of the different kind of pavement was. Because in the Knossos model, you not only calculate what happens for the vehicles, but you calculate also a contribution from the road. The bad part is that this contribution in the Knossos model is also dependent on speed and on frequency. So more calculation to be done. So here we have a confrontation between the cells we obtained on the two pavements, and there is a dashed line that is the difference frequency by frequency between them. We can see that the chrome rubber resulted a little bit louder in the low frequency range, but it was better behaved from 1 kilohertz, around 1 kilohertz, and that's what we like, because this is the range in which the main part of the emission is collocated, and also the frequency range that we can hear better. Then this is the formula that we had to solve exactly like before, but there is not there is some differences. For example, in this case we have all the dependencies we had before, but the beta parameter do not depend on frequency, while the alpha parameter does. This is sort of saving grace. You can do the calculation a little bit better. And that's the results for the parameter we obtained. These are numbers that are not very interesting. I will skip above this because I wanted to show you the scenarios we simulated with those data. This is what happens in the Knossos model when we put the data for standard combustion engine vehicles. This is what happens if we have a mix of 50% electrical vehicles and 50% combustion engine vehicle. And this is what happens if we have only electrical vehicle. So we like green colors much better than red ones. This is the same thing for these images seem similar, but one is a scenario for the P pavement, and this one is for the PCR pavement. I can tell you that it is not easy to see, but the PCR is slightly better This is the emission, the overall emission, A-weighted band emission. These are the differences between the scenarios. So the differences between 0% electrical vehicles and 50% electrical vehicles are about 2.5 decibels in average. But better things happen when you pass from 0 to 100%. We have simulated 7 decibels at least of noise reduction. It is quite a lot. This is the betterments we have with the crumb rubber. They are a little bit better, but we are within 1 decibel. And that's it.
Thank you, Francesco, for the interesting presentation and also for the many nights spent in via Paesiello to take the measurements.
But there was an oven nearby that produced us focaccia at the end of the measurement. So that's why I'm still here.
Okay. And then the last presentation of this morning, we want here to hear the voice of the citizenship, and Chiara Bartalucci. She's a PhD environmental engineer, expert in acoustics and soundscape of Via Rosa Ingegneria, will present the results of the soundscape analysis and the people perception on what we have done.
Okay, thank you, Raffaella. Good morning, everybody. Yes, as Raffaella said, I will show you a mix of information and results about our activity of Via Rose and about the overall project. In fact, first of all, I will tell you about the ante and post-operam perceptive survey that we carried out with residents close to the pilot area. Then I will show you results about the comparison between ante and post-operam noise measurement campaigns. And last, I will give you some numbers about dissemination impacts of our project. So let's start with the perceptive survey with residents in the area of Paesiello Street. First of all, a couple of days before the questionnaires delivering, an informative letter has been provided to the residents, and then informative letters and questionnaires have been delivered directly to the residents' mailbox. And then we personally collected the filled questionnaires from residents. So here you may see the structure of the ante operam questionnaire. We have several sections dealing with personal data, the information about the dueling, then the central section that is about the perception of soundscape and landscape. Then we have the expected effects of the planned interventions, since it is the ante operam questionnaire, and then a question about the sensitivity to noise of residents. Regarding the structure of the post-operam questionnaire, it is of course very similar to the previous one. We have some differences concerning a section about traffic noise, because we wanted to understand if residents perceive changes in traffic noise. And the other difference is the next section, that is about the effects of the implemented interventions, the effects on traffic sounds, the effects on the value of the property, and then possible effect on personal health. So here are some numbers about the questionnaire. In the ante operam phase, we delivered 92 questionnaires for 56 filled questionnaire. In the post-operam phase, we delivered 101 questionnaires for the same number of filled questionnaire in the post-operam phase. So here are some outcomes related to the ante operam phase. We selected just a few questions of the questionnaire. So, for example, you may see that in the ante-operant phase, residents evaluated the soundscape around their home to be of fair or bad quality for the major part. The same thing about the perception of traffic noise. As Arnaldo said before, Paisiello Street, for those of you who don't know the street, is a very busy street with a lot of vehicles during the day especially. So citizens evaluated the intensity of traffic noise to be very high. Regarding perspective questions, for example, citizens also think that their health can be affected by traffic noise. So in some way they are already conscious about possible bad effects. And for the major part, they told us to be high or medium sensitive to noise. So here you may see a comparison between results achieved in the ante and post-operam scenario. So you may see a change, for example, in the perception of traffic noise that is higher in the ante-operam phase with respect to the post-operam one, and also a change in the perception of the overall soundscape, because also in the post-operam phase, the soundscape perception is not so good, but of course it is better than in the ante-operam one. Other comparison, for example, citizens perceived changes in noise traffic in the post-operam. They saw that traffic is decreased in some way. The intensity of traffic noise is decreased. The effect of the intervention is evaluated as positive in the end. And they also think that an intervention such a low noise asphalt can increase the value of their property. So I think it is also an important outcome to be evaluated. Then after this phase of descriptive analysis, we move to other typologies of statistical analysis. First of all, we carried out this Pearson chi-square test that helped us to understand which variables of the questionnaire can be evaluated as significant depending on the ante and post-operam scenario. The main result is that we selected the variable soundscape quality, which turned out to be sensitive on the ante and post-operam scenario. So after the selection of this variable, we built regression models in order to establish if there were some relationships between the response variable, the soundscape quality, and other covariates, among other questions of the questionnaire. So here, just to show you the structure of this model, you see in brackets the variables that we selected. Of course, then there is a table with the coefficients, but then I will try to summarize in a descriptive way which are the results. In fact, here you see the main outcomes of the model. Regarding traffic sounds, we see that who did not vary the response between the ante and the post-operam period, or who responded that they heard less traffic in the post-operam phase, tended to give a higher score on the soundscape quality. So there is this relationship between traffic perception and soundscape quality. The same relationship we found among nature sounds and the same quality of the soundscape. So citizens perceived a positive relation between the reduction of traffic noise and between the increase of natural sound and the perception of a good quality for the soundscape. Then other consideration regard the variable concerning the interest and relaxing environment. We noticed that in the first case, those who find the environment interesting in the same way in the two periods tend to perceive a better quality of the soundscape, and who perceived the environment as more relaxing in the second period gave a higher score to soundscape quality. Then, of course, who declared to be sensitive to the environment in the same way tend to perceive a better soundscape quality still in the post-opera phase. So these are the main outcomes concerning this survey that we conducted among residents. Just a few words about another typology of noise measurement campaign, which has been carried out at the facade. This is related to the first part of the presentation because we wanted to have an objective base to be next to the evaluation of the citizens. So we carried out a long-term ante and post-monitoring noise campaign that has been carried out by Vienrose together with iPool partner. So we have defined two different monitoring positions. One in the road section that has been interested by the new asphalt designed by the project, and the other in the section interested by a new but standard asphalt. Of course, we also positioned a traffic counter in both phases and in similar position in order to be able to weight traffic and to measure noise levels according to the traffic flows in the different periods. Here you see important results of this campaign. Of course, according to the methodology, we excluded the rainy days from this evaluation, and we considered in all periods weekdays. So you see, concerning the asphalt of our project, a reduction in terms of LEQ of 4.4 dB as L-night, and still, of course, a reduction according to the new standard asphalt, but a lower reduction in comparison with the asphalt of our project. So just a last slide about the dissemination impacts of our project, because dissemination was in charge of Vienrose, and we think that these numbers are really important. These are not, of course, the very final number, but they are now they are important. So, for example, you see 12,000 visits to our website for more than 2,300 users. Many sessions also on our social network with considerable average visit duration, in particular concerning LinkedIn. Of course, we also produced many scientific papers, some of them presented, of course, also during conferences. It is also very important that the project directly addressed many students in Europe, 60 students directly informed about the project, and especially concerning the pilot case realized in Florence, many brief articles have been published on Italian magazine. And then, of course, the participation to the webinar that we organized last year about the project had a considerable number of participants. Of course, our website is still online, so if you want to visit it, to download the materials, feel free to go there. So I finished. Thank you very much.
Thank you very much, Chiara. We are perfectly on time, and now it's lunch time. I remember for the acoustic technicians to sign the exit for the break, and there is a lunch box available for participants, which is kindly offered by the municipality of Florence in the stand of the municipality just behind this wall, and we start again exactly at 2:30. Please be punctual because we have the first connection that is starting at 2:30. And thank you again for being here, and see you later.
Ok, good afternoon, buon pomeriggio, per favore prendete posto perché fra qualche minuto iniziamo e anche se c'è qualcuno fuori magari che conoscete, diteli di entrare e di prendere posto. Please take your seats, in a couple of minutes we are starting the afternoon session. tuo funziona, Daniele? Se no ti passo questo. Che non è tanto light, è una bella bomba. Io mi sono accorto quando ero a 3/4 di schiacciatina, che te buono, una bomba, sono fermato e l'ho lasciato. Io appena mangio sempre un'insalatina e basta. Bene, ma purtroppo mi rimane il problema al cuore e abbiamo fatto degli approfondimenti e dovrò operarmi. Non si sa se urgentemente o no, perché ora sta... Però sto bene, non è sintomatico per niente, però c'è un ingrossamento dell'aorta che insomma può diventare rischioso se continua a ingrossare, a crescere l'ectasia, poi mi impedisce di fare le mie attività e ora sto proprio bene, quindi vorrei risolvere anche questo, prevenire. Cioè nell'occasione della fibrillazione atriale hanno scoperto questa malformazione, probabilmente antica, genetica, che però ora invecchiando si dirà. Aspettiamo ancora qualche minuto che finiscano le operazioni di firma. Let's wait some minutes more, waiting for the signature operation. Okay. Don't forget that this is for the acoustician. TCA, don't forget to sign the presence, otherwise you will not be, the credits will not be recognized. Sara, posso andare? Okay. Let's start the afternoon session. Good afternoon, ladies and gentlemen, dear colleagues, dear friends. Very nice to be here again after the very interesting morning session. This afternoon session is devoted to the networking among projects that deal with acoustics, of course, deal with asphalts, deal with the solution that has been mentioned in the introduction given by the EU officers. And we talk about other projects. Many of them are LIFE projects. You know, LIFE is l'instrument financier pour l'environnement. Sorry for my French. Sorry for my French, but it means that is the financial instruments for the environment. This is the acronym of LIFE. And some of these projects are for the environment. And it's a fact that one of the priority in the last year is actually the problem of tires, asphalts, and so on. And it has been proposed a couple of times ago of not the last, but maybe 2 calls before, and it's been also confirmed later. So the problem that we are focusing today with the eVia project, but also with the other project that we are going to talk about now, is a real problem, as they say in the morning, and it's a problem that has still remain a problem also for the next years. So we started to talk about this, and this is also the way I want to introduce the first speaker, more than 10 years ago, when for the first time we started testing the effectiveness and the performance of new asphalts made with rubber, the rubberized asphalt, compared with the traditional asphalts. And it was a study that Ecopneus funded, and together with the Toscan region and other regions that were in the mood of the noise reduction plans after the noise classification plans. And some of the paving intervention were tested comparing with more or less sophisticated techniques like the SPB, the CPS, and so on, comparing the traditional and the new asphalts. From our side, it was the first time, and then I see, and we see now in this session, that many other experiences have been performed in the frame of LIFE projects and also Horizon projects. So let's start talking about this, and it's my pleasure to introduce Mr. Daniele Fornai. He is one of the main experts we have in producing, organizing, managing the producers of solutions and of the recycling of rubber and many other things. Ecopneus, that he represents here, was one of the partners of the Nereide projects, and this is the title of the presentation: Nereide, noise efficiently reduced by recycled pavements. Daniele, the floor is yours. You have 20 minutes.
Okay, thank you, Sergio. You have already summarized whatever I had to say on my presentation. So, well, yes, the Nereide, first of all, I'm not an acoustician, so I will surf just on the surface of the topics, and I will not go into the details, so don't ask me what I'm saying about acoustics, but I trust that some of the members and the partners of the projects are here, and so they will answer to your questions, if any. Anyway, the project was born out of an idea. The question was, can we try to reduce the traffic noise by making an efficient use of recycled materials? And by recycled materials, we had in mind rubber from tires and reclaimed asphalt pavements, so the waste, the end-of-life roads or asphalt. In fact, looking at the statistics, Italy is not in a top position as regards the recycling of reclaimed asphalt pavement. So in 2021, the National Association released this information that only 30% of the reclaimed asphalt pavement is recycled. And this is a poor result if you compare it with the European average or with what happens eventually in California, where 98% of reclaimed asphalt pavement is officially recycled. At the same time, also, end-of-life tires recycling is not so easy in Italy, as the market demand for recycled rubber is not so huge or not as big as we would like. And so about 60% of the tires tires generated every year, and the end-of-life tires generated every year, are used as an alternative fuel in cement plants. But as having a license for using alternative fuels in Italy is quite difficult. Most of those tires are sent to Turkey, to the Turkish cement industry. So we are all spending our money to the benefit of the Turkish cement industry. That's something that we don't like as a company. But my company, Ecopneus, is owned by the 6 major tire manufacturers that has an extended producer responsibility. And so since our foundation, since 2009, we started monitoring the asphalt trial sessions laid with rubberized asphalts of any kind across Italy. And so since 2008, about 670 kilometers of trials of asphalt pavements made with asphalt rubber or whatever rubberized asphalt pavement you can think of have been laid. That is, once again, a poor result if you compare it with the Spanish results that in Spain over the same time, more than 7,000 kilometers of asphalt, rubberized asphalt pavement were laid. But at the same time, I must say that most of the interest of the local authorities and administrations was focused on the possible noise mitigation thanks to the use of optimized rubberized asphalt pavement. And so because of this growing interest, 2 main technologies are spread across the country. The first one was the American one, or the asphalt rubber technology, that is quite old one. It is more than 50 years old. And a new hybrid ride technology that makes use of rubber in a slightly different way, but it is as performing as the asphalt rubber and the conventional asphalt rubber. But in order to reduce the traffic noise, so that is mostly by avoiding any kind of excitement of the tire rolling on those surfaces. The control of the texture is key. So the maximum size of the aggregates and the texture is key. And guaranteeing this kind of smooth and regular texture can be a challenge when using reclaimed asphalt pavement that sometimes in some plants is not managed appropriately. So this were the basis that we started with when drafting the project. And so the aim of the project was just to assess and to develop the mixed design and to assess the acoustic performance of environmental sustainable asphalt pavements that might integrate a high content of reclaimed asphalt pavement and rubber at warm temperature, so at a low temperature. So the expected goal were to use valuable materials, as I said, so reclaimed asphalt pavement, so aggregates and bitumen coming from reclaimed asphalt pavement and rubber, to achieve acoustic performance better than those provided by conventional materials, so to upgrade a little bit the performance, the acoustic performance, especially in urban areas, and to improve safety, so to guarantee the appropriate friction and roughness of the pavements, and finally, eventually also to improve the air pollution by making use of warm mix asphalt additives or techniques, so by reducing the temperature during the production and laying of the asphalt mixes. Well, I didn't notice that this compressed. Oh yeah, it has changed the format, so you cannot read my writing. Anyway, the results of it has compressed a little bit, the texture. Anyway, the outcomes of the projects were the development of 6 or 12, depending on the point of view, new different mixed designs that included either open, so porous asphalt, gap graded, that is almost similar to an SMA, and dense graded mixed asphalt, that is the most common one at least in Italy, later in Italy. Either the wet and the hybrid dry technologies were tested, and both with the use of a warm mix asphalt, so the temperature of production was not exceeding 140 degrees. That is something that is relevant, as when using rubber, the American technology requires a higher temperatures than conventional, so 170, 180 degrees. So reducing that temperature was important also to guarantee better safety for the workers on the road. So finally, also we achieved a quite good target by using up to 25% of reclaimed asphalt pavement in those wearing courses. As an average, it was between 15 and 20%. For guaranteeing the best acoustic performance, and in the 4 kilometers of trials that we made during the project, we were able to use 42 tons of crown rubber, so recycled rubber from tires, and more than 300 tons of reclaimed asphalt pavement, by saving 118,000 megajoule of energy thanks to the warm mix technology. The results were quite good, either on the structural or mechanical point of view, and also from the acoustic point of view, and also the monitoring on the friction and the stability of those materials that are still going on confirmed that the materials that were laid have good mechanical performance and durability. So as regards to the acoustic performance, during the project, 2 new test methods were developed, and with new prototypes that were developed. I can say more than that. And on as regards to the acoustic performance, on the 2 sites, trial sites that we used, either on porous or dense graded asphalt, a reduction of noise by from 3 to 4 dBs was measured. And in terms of disability adjusted life years, it corresponded to a reduction of 4. At the same time, something similar to the psychoacoustic assessment that was carried out also with the EVIA project was performed by means of interviews and surveys, and all those results showed a general positive impact on the perceived noise by the inhabitants, the local residents. Other results based on the life cycle assessment, by making use of recycled materials, and at the same time by making use of warm mix asphalt technologies, it was possible to reduce the total environmental impact by 50%. That is a relevant reduction, and also by using the even more important, I would say, by using the warm mix asphalt technologies, so by reducing of 30 degrees the temperature during the laying down and the compaction phase, it was possible to reduce also by 30% the exposure of workers to polyaromatic hydrocarbons, that are carcinogenic substances that are commonly present in the fumes of asphalt, because it is one of the components, and not only the polyaromatic hydrocarbons, also other harmful substances that are commonly present in bitumen fumes were strongly reduced. So by reducing the energy consumption that is nowadays so important, we can have also a safer environment for the workers. We can save energy, we can reduce the environmental burden, and we can make use of recycled material by reduce at the same time also the traffic noise. So a bonus outcome of the project. Thanks to one of our partners, we dealt with the ANAS, that is the National Authority for the construction and maintenance of most of the roads here in Italy. And ANAS in 2019 launched an experimental trial to develop their own asphalt pavements aimed at reducing the noise and also possibly being more environmental friendly. And so they used and tested also two of the mixes, four of the mixes that were developed by the Ready project, that were also had been tested also in another project led by the Regione Toscana, the Leopoldo one before. And okay, there's no more. And based on the excellent results that they get, they finally introduced two mixes, either the wet ones and the hybrid dry ones, into their national specifications. And that's a huge leap toward a circular economy. If you think that it took me more than 10 years of meeting and negotiation with them just to have them accepting the idea of considering rubber, and so just by having some positive results that came also out of this project, they decided to have it and to use it. So it is in the price list of the ANAS and into the national specifications. So it is really a first important step that can be followed also by many other authorities and administration, local administration. And that's all. That was the good news. Thank you very much.
Thank you, Daniele. Thank you for your nice presentation and for being perfectly on time. If there are questions, I kindly ask you to, as we did in the morning, to just take note and wait. We will discuss later. If we save time during the presentation, is even better, so we have more time for an open discussion, since all the presentations are more or less in the same frame, that maybe it's nice then to discuss together of all the themes of the morning and of the afternoon. So I invite the next presenter, and the next project, again, is a live project. We have 3 live projects and 1 horizon in this session. The second project is about noise and vibrations produced by tramway track and road traffic, both. So we have a kind of overlapping of sources and of effects. The presenter is Francesco Borchi from the University of Florence. University of Florence is one of the partners of this project, and the name of the project is SNIC, Optimized Surface Against Noise and Vibration Produced by Tramway Track and Road Traffic. Francesco.
Okay, thank you, Sergio. Good afternoon, everybody. And this project, the SNIC, is focused on develop solutions for road traffic noise and vibration, and also against tram noise. The project is coordinated by the Municipality of Florence, and have some associated beneficiaries. Astra, that is a main coordination about the dissemination of the results, and other part is Ecopneus, that give all support in the investigation of the state of the art of technology about rubber and possible low noise paving solution based on camber asphalt. After we have the University of Mediterranean of Reggio Calabria, that we have listened in the morning in the EVIA project, that is in charge for the designing of the new noise paving, low noise paving, supporting by the MOPI, that support the university for the analysis of the mixture and experimental measurements. After this, we have the University of Florence that is in charge for the designing of the solution for tram noise. And the last is the Vienrose, that is in charge for all the investigation and noise measurements and vibration at roadside and receiver's position, together with the analysis of perception according to results obtained with the new solution. The overall objective, as I said, is the reduction of noise and vibration. And the solution investigated is in the pilot area, that is via La Marmora in Florence, is a low noise paving to reduce noise and vibration due to the road traffic noise, and some onboard solution for tram, because a new tramway will be realized in the La Marmora Street, the line 4. So we experiment a new solution. In particular, we in the project proposal have defined some type of possible solution, boogie skirts, some absorbing panels, and water spraying system, and that is a possible onboard lubrication system. But according to the current lubrication spray that is installed in the tram line that is currently work, we have decided to for the moment to skip this intervention. The expected impacts about this project is very challenging. About the road traffic, we expect to reduce at least 3 dBA. We work with the traffic that is conditioned also from light vehicle, but also from buses. So it is an important reduction we ask. This is verified according to roadside measurements, but also by using CPX. On the other hand, on tram noise, a reduction of 5 dB is expected as broadband results. And we expect also a very challenging results, 20 dB on attenuation about squeal noise. Really cause this means that the solution should be eliminate the cause, the squeal, because this is but if we can obtain this with only with the lubrication system. The other point is the vibration. We expect also a reduction on vibration. Is a low target, but is important because it is one of the aim of the project. And after this, we expect some CO2 emission reduction. People annoyed. And of course, life cycle cost is a reduction also in this about this point, and so on. Policy implication. This project have a direct implication about the directive, because as it was explained in the morning, it could be an important adding value in the analysis of coefficient requested by Knossos for the new asphalt, designed asphalt. And the other point is regarding the citizen perception. That is an important point investigated by the project. And reduction of vibration impact, of course. Case study is Via La Marmora. The particular features is road traffic and buses running at low speed. So this is the starting point of the case study. Some slide is missing. He jumped from 6 to 17. Jump the asphalt. I don't know. Okay,
if you want.
Okay. Yes, just okay. Okay, we can speak about the tram noise that is. No, it's not problem. Tram noise is the solution for tram noise is the solution designed and implemented from my institution, from University of Florence, and okay, wait a moment.
Yeah. If they solve the problem, I think we can go on. Otherwise, we can suspend this presentation, then solve the problem, and.
Okay.
Okay, you have it.
Yes.
Fine.
Yes.
Good technician.
Okay.
Efficient.
about road traffic, the first intervention is about a designing of low noise vibration paving. What is new? We have a similar approach. We have same designers, because University of Reggio Calabria is also in the other project, the VIA project. But we have other additional challenge. In particular, it will be studied a mixture that can work also on the vibrations. And this is the first point. The other point is work with aiming to a warm mixed asphalt, so laying at low temperature. So I have only some slide, some pictures about the experiments, about the different mixture. We are the university with support of MOPI are studying to design the new asphalt. So I can go on. I have only some picture about this. And so this is the adding value that can be offered from this project, referring to the EVIA project, because he studied for vibration, and this project study for a case study that consider the presence of buses, that is an important source of noise and vibration. So I can jump to the other intervention. The presentation is will be free, I think, for people. About tram noise, the other intervention we designed as University of Florence, we work on onboard solutions, and here is the main sources that we have to consider referring to tram noise. And we have in urban environment at the speed under 50 kilometers per hour, contribution from engine and rolling is a minimal part, but is significant. And when it happens, the squeal noise that can cause a real important problem. But about squeal noise, we consider to have the lubrication, current lubrication. And we have studied other possible solution that we can implement in for reducing, have an additional reduction. And the solution, the selected solution is work with the buggy skirt. There is some skirt that cover the buggy in the normal way, in current state of the art, but this cover normal is not designed for noise attenuation. So we have work to implement the noise reduction, obtain noise reduction, and this is obtained from two ways. The first is to enforce and improve the cover, giving a a good impedance and for transmission, but improving also and some absorbing panels that can reduce all the reflection under the bogie. This is the main concept that we have considered. So increase the barrier, the height of the barrier of the cover, and increase the sound absorption of the panel. Here is the current cover, and we work on the current cover. We study the solution with a VM acoustic model, and our proposal is to enforce the cover with a special metamaterial with a designed impedance. Results are very impressive. We have I think you cannot read the table, but on table on the left side, here is the specific noise measurements that define the noise emission caused by the tram without curves. And so we have only the noise coming from engine rolling, and we have a specific we have a broadband noise, but focused from 600 hertz to 1500 hertz. On the other side, we have specific contribution at specific frequencies around 2500 hertz for squeal noise. We test this solution, and we obtain, as I said before, impressive results, because obtain 10-15 dB of attenuation in simulation from at this in this frequency range. So we are implementing at this stage the prototype with the help of the constructor of tram Hitachi. Okay, so conclusion, new solution, the SNIC project define and try to design new solution to reduce noise and vibration, road traffic, buses in particular, and tramway. Design of this new paving solution, starting from the state of the art, the EVIA project is a very starting point, is a part of our state of the art, of course, and we aim to obtain also additional features about reduction of vibration. Referring to the solution on the tram, we are developing some bogie skirts and some absorbing panels optimization to reduce noise. Okay, we expect to realize the prototype of and the new asphalt at the beginning of 2023. Thank you.
Thank you. Grazie Francesco. Let's go to the third live project. We move to France, because the project is called Cool and Low Noise Asphalts, and it deals with not only noise effects but also thermal effects. The project is a live project, as I said, is coordinated by the city of Paris. Among the partners, there is Bruit Paris, and we are in connection with, in remote connection, with the speaker from Bruit Paris. That is Antoine Perez Munoz. The floor is yours. Please.
Thank you very much, Sergio. Can you hear me well? Is it okay for you?
Yes, perfectly.
Okay. Shall I share my screen with you? Okay, I hope you can see my screen, my presentation.
Yes, fine.
Okay. Good afternoon, ladies and gentlemen. So I'm Antoine Perez Munoz. I work for Bruit Paris, which is a non-profit association and the Observatory of Noise in the Ile-de-France region, which is the region of Paris, France. And we are involved in the project, as Sergio said, the live project Cool and Low Noise Asphalt, which is coordinated by the city of Paris. And we're involved in the assessment of the acoustic performance of low noise pavement, which are spread in the city center of Paris. As you probably said this morning, these actions to reduce noise generated by road traffic in urban areas involves, of course, a combination of several actions. And among those possible actions, that's what the event is about, the laying of low noise pavements appears to be a promising one to solve the problem at the source, as well as the other solutions are in reducing the level of noise traffic itself, or tackling especially the noises to vehicles. So various evaluations of the subject are carried out by Bruit Paris in the France region, on the Parisian ring road, for instance, and as well as several highways in the Ile-de-France. It's a long-term, at long-term scales. This first picture to tell you about the situation in the road noise problem in the city of Paris. This is what appears in the strategic noise maps. In fact, these are the round 3 of the European directive. The round 4 maps, city maps, are not yet available. So this, in fact, was the situation in the years, let's say, 2014 or 2015. As you can see, this kind of purple ring around the city of Paris may encourage public policies to focus on the Paris ring road, which was done since then. In fact, speed limit on the Paris ring road has been limited to 70 kilometers per hour, and low noise pavements on the ring roads are widely used. Yet, these maps, for those who know a little of Paris, shows that people living in the inner city of Paris might also face high levels of noise, for instance, maybe around the Champs-Élysées area or along the banks of the River Seine. So it's indeed interesting to experiment acoustic coatings in the downtown area with traffic speed limits where by the time 50 kilometers per hour. And keeping in mind that it could only, as these studies or inquiries show, that it could only solve a part of the problem at the best, as well as improvements in motor emission already had. That's what you can say. And knowing that complete solutions will have to be sought towards sources of noise peak, for instance, which seems to be a major source of complaints for habitants of Paris. So this is why the city of Paris embarked in the cool and low noise asphalt project, combining acoustic and thermal properties to tackle both road noise pollution and global warming, which is of course a major issue right now. So this project is, as said, takes part of the European LIFE program. So the innovative pavement surfaces were developed by technical partners, societies Colas and Eurovia, Bruit Paris for acoustic monitoring, and Paris University Lab for thermal properties monitoring. So this is the detail of the project's objectives. So the three new types of asphalt mixes gathering both phonic and refreshing properties, and an important point, maintaining or aiming acceptable durability were developed by our technical partners. Here are on this slide the specifications. On the noise aspect, the prior objective is to reduce the noise emitted by the contacts of vehicle tires with the asphalt, so the rolling noise in urban roads thanks to this new pavement. And of course, the level of performance should be high enough to be perceived by local population and lasting. This is the reason why inquiries were conducted. On the thermal aspect, I won't say much about this because I'm not a specialist. The objective is to mitigate the effect of urban heat islands by testing the surface retention capacities, the microclimatic impact generated by the spraying of non-drinkable water during hot periods in the summer in Paris, and also the effects of the albedo, the color of the asphalt on the heat restitution. And concerning the durability aspects, of course, the objective is to reinforce the durability of these coatings in terms of the acoustic, the mechanical, and the thermal properties, while limiting their additional cost compared to conventional coating in order to promote the dissemination of this solution widely in urban areas. So the new formulas were tested on 3 pilot sites, each 400 meters long, in 3 Parisian sites heavily exposed to road noise, not quite in the very center of Paris, but in noisy and crowded boroughs. Particularly, it was important that the road selected where the speed limit was remaining at 50 kilometers per hour, and road works had to be already planned so that it would be easy to include the experimental coatings in this program. So in 2018, each site has been coated halfway with the experimental formula, the 3 ones, and the other half with the Parisian standard pavement in order to compare both performances. So road section, each road section are about 200 meters long, both experimental and standard pavement. Each site equipped with various sensors so that the performance can be compared, as I said. Overall, 6 acoustic stations, 8 thermal stations were positioned between the roadway and the facades of the building. Also, digital audio recording on the roadside and continuous CPX noise measurement were conducted. So it consists in, as you probably know, measuring the noise emitted near a rolling test tire, and also measurements of mechanical durability, micro roughness, macro texture, and in situ survey of small degradation were carried out. Here you can see the precise location and of the new coatings, and yes, you see the roadworks were conducted throughout the summer of 2018. So here are some of the results that can be presented here that we obtained by now. Concerning the facade of the building, the reduction of enrolling noise between the standard coatings in red here. I'm not sure how wide your screen is, if you can see it correctly, but in red is the standard coating, and in blue the tested one. So the reduction is clearly observable at night, which was expected during the passage of isolated vehicles, and when the traffic speeds are relatively high at night, and the other sources of noises are reduced. Thus, the LA10 between 10 p.m. and 6 a.m. indicator was chosen, as it clearly reflects the reduction associated with rolling noise. For the other periods of the day, the acoustic indicator show benefit, but a reduced one. The project's objectives in terms of persistence of the performances in reducing rolling noises compared to standard solution have, you can see here, almost been achieved for two of the coatings, the SMR Foam and the BB Foam Plus. And for the Puma, the performance of the pavement unfortunately could not be evaluated at the same time due to technical problem on the segment equipped with the reference coating. But the performances seem to have an interesting remaining in time for this the two of them. Some result by the CPX method. Here you can see the CPX vehicle, which belongs to the city of Paris, and the realization of the measurement at night. And here too, the project objectives in terms of the reduction of rolling noise are achieved, or almost achieved, which was almost 5 dBs reduction short after the roadworks in 2019 to remaining 1 dB reduction in 2022. This last slide shows the acoustic result, this time for all sources of noise combined, not only rolling noise during the night period. So you can, depending on the site, noise reduction is still at least around half a dB in 2021. You can, this is a figure to be selected and reelected, which also questions about the feelings of the local population. In other words, does the ability of the human ear to distinguish sources of noise make it possible to feel and acknowledge the benefit provided by this innovative asphalt mixes for the local residents? So that's why, to try and answer that question, as I said, surveys were carried out both on pilot sites and online to have as many answers as possible. This was a part of the program that was expected by the LIFE program. So as you see, in October 2019, surveys were conducted in the Frémicourt street, one of the 3 sites, and 63% of the question noted a reduction of the road noise following the change of road surface, which was less than a year after the roadworks. And among them, 67 considered this reduction to be medium or significant. The second survey was conducted in September 2021. The questions were a little different. it occurs that 85% are in favor of extending the solution to other Parisian sites, and 73% have an overall positive assessment of the project. So cool results for us and for the city of Paris. It seems to have this additional qualitative elements in terms of feeling are crucial to include in the story and in the study and in the overall assessment of the project. So to conclude, the long-term monitoring, which means afterlife program, this will allow us to document to keep on documenting the evolution of acoustic and thermal performance over time, which mean at least until 2028. By now, these innovative products are considered relevant, so they have been integrated into the catalog of road surfaces used by the city of Paris, and so these solutions are to be implemented at other sites in Paris. An important last point, the quantification of socioeconomic impacts, which was planned under the project, are currently being assessed, and this assessment will take place along 2023. So thank you very much for your attention. Of course, you can.
Thank you.
Please feel free to visit the Life Asphalt website and have this announcement. Feel free to register to the coming event, which is called Cool and Quiet and Cool City Conference, which will take place in Paris in April 2023. Thank you very much.
Thank you again, Antoine, for this very nice presentation, and also for remembering us that the results of the projects and also the networking among the projects sometimes survive to the project is longer than the project time. It means that, okay, today we are speaking of living project because most of them are still open, they are still working, they are still producing results. But we are sure that a good project is a good project if its results survive to the project time. And sometimes it is nice also this afterlife program that for the life project make mandatory to the partners to provide the public with an afterlife program. So I think that it is interesting also to talk about the perspectives, and we will try to do this in the round table that will follow the session. But now it's time to close this session with the final presentation. This is not a live project, it's a Horizon. It's a part of the Horizon program. The Horizon program is larger, and the projects larger means that it finances huge projects. And the project that we are going to talk about is a huge project. It has a large partnership, larger than the partnership that we had for the life. There are 18 partners from 11 countries, 7 demo sites, also a larger funding, of course, since the partners are many. And it's my pleasure to ask Gaetano Licitra to give the presentation about the project NEMO, or NEMO, I don't know how is the right pronunciation. The acronym stands for Noise and Emission Monitoring and Radical Mitigation. Gaetano.
Thank you, Sergio. Good evening. I close this session with another project, as Sergio said. I don't know, it's going on. Sergio.
Sì, quello. Doesn't work.
Okay. they are trying to solve.
Fine.
Yeah, okay, thank you. The project is an Horizon 2020. The project will close the next year. Excuse me? Okay. The project is closing in the next year. The idea is to build a system to recognize the high emitters. High emitters in terms of air emission and also noise emission. Why? Because in our city, but already someone else said in his presentation, people is annoyed by the level, sound level. Above all, when someone say motorcycles. Why? Because motorcycles are higher emitters in some way, respect to the cars. But also there are new kinds of cars, you know, SUV that are noisy respect to the others. And also there is the behavior of the people that sometimes accelerate a lot and also change the structure of the motorcycle for the exhaust pipeline and so on. So you know that noise is measured by logarithmic units, and there is a big difference between 73 and 70. No, you know, is the double of energy. So when you have an high emitter, you recognize, because our ear is a logarithmic tool in some way. So what we try to develop in this 6 million DAF project, as Sergio said, with a lot of partners, was try to integrate different parts, different. I mean, because also the people react with an holistic approach. I mean, we are not only ear or eyes; we are human. So we are in a city, and we want to improve the quality of the life in the city. The idea was also to implement solution, and sometimes solution means also not only mitigation, like the other project proposed here, so a new asphalt again, but also a system to recognize these high emitter and block them, or in some way push these people to go to somewhere where it's possible to again maintain the vehicles and reduce the noise or the air quality. We have in Italy every 4 years or 2 years, depending on the age, we go in a place, we have to check. But also we know that maybe there are many of them that needs to go there, not waiting for 4 years, because the maintenance of the vehicle maybe needs that. So in order to do this, the goal of the system is to try to build a database of all these kinds of measurements, and to recognize the different situations in which these appear. Looking for the mitigation, and one solution proposed is like a green noise barrier. So a system in which it's possible to use the green in order to reduce the pollutants. We know that this is good if you have like a pump of air, because otherwise trees can do something, but you need a lot of trees. So if you want to improve, you need some systems to do that. Also, there is another problem about the microplastics. We know that with the last studies that maybe 30% of the microplastics in the sea came from rubber. This is something that people don't know, but the last studies say this. And the big point is how many cars we have, how many pneumatic you change, tires you change, and because you lose rubber. So it's quite easy to understand why you have so much quantities. And so we need surface payments that try to reduce this production. Otherwise, we have a problem for other things. But we know, as Filippo said before, that it's not easy to combine any needs, because if you have low production of microplastics for the wearing of the tires, and also Carsten say that how much is important, and they try to improve that. But you have to combine this with not only the rolling noise, but also with the friction, because you need to stop your car, brake. So again, environment is a complex word. You have to combine many, many needs. These are the partners, so you can see that there is really all the Europe. I worked also to build this network, and it was not so easy to find so many countries, but with people that worked on air quality and noise, and also with IT systems. And okay, you can see here, there is also University of Gustav Eiffel, so I mean, our colleague is in the same partners there, and also Municipality of Florence with ARPAT. You can see here some of the devices, but I will show you in a movie, in a little movie, in a few minutes. And the system are for emission, so E, RSD, and for noise, N, RSD. And these systems works for one lane, but also for more lanes, depending on the position of the source of the device that can make the measurements for that. But we can see more after. For the air emission, we use a system with 12 different lasers that intercept the exhaust and recognize different pollutants. So you can see what happened in that moment for each vehicle and for different pollutants. For noise, we use other microphones. So 2 microphones, but I will show you. Okay, now they are preparing the video just to give you the idea of the work more easy and more clear than me.
Imagine a low emission zone where only low emission vehicles
Come back. Oh.
Imagine a low emission zone where only low emission vehicles are allowed to enter. So it becomes time critical that the driver receives the information if he's a high or low emitter. And therefore these kind of conditions we are testing here at Teesdorf. The sound system is developed by our partner Müller from Germany. It is developed on the human hearing because the human hearing can identify the source or the noise from any location and direction. Here we've got our emission measurement system developed by Opus RSE in Spain. And the emission measurement system is a quantum laser cascade system, which means that for each gas there's a different kind of laser, and we have got 6 different lasers here inbuilt with this system. In addition, we have got here a speed and acceleration system measuring the vehicle speed and acceleration because it makes a difference. The system produces results within half a second. For integrating all these measurements, we use as a basis the Kapsch tolling system, which has been developed over quite some time and is applied worldwide. The key of the Kapsch tolling system is the integration of all the communication between these systems, so the vehicle recognition, the number plate recognition, the communication to the car, and now the measurement of the emissions plus the noise is integrated as well. It is possible now to identify the vehicle and send then a message to the car within 10 seconds in order to identify him as a high or a low emitter. That's the reason why this is a first time that these measurements have been taken place and that the European Union selected the NEMO project as one of their key research projects.
Okay, come back to the presentation. Okay, a few seconds. Okay, so I am the project leader of this work package that is the case study, a pilot study in Europe. So I will show you something about the different case study that we are doing in this period. So in Florence, and we already did that. There will be another in Madrid, in Valencia, and the next week I will go there. And finally another one for the railway that will be in the Netherlands. So we are in this part of the project. So the first 2 years were to build all the system, test, to make all the software that we need, and I will show you what is now and what will be in the next month. In Florence, obviously, I propose Florence for the collaboration that we have with the municipality of Florence and also the experience that they acquire in this year with the LIFE project that you have already seen. The idea is develop in Florence a new kind of payments, I say before, and also to test the device that we develop in the project. The other will be in Madrid, and because in Madrid there is a LEZ, so it's a low emission zone, so it's possible to filter the vehicles that can come in, and with this system is also possible to check if they have the possibility to come in or not. And also they will test the multifunctional barrier, so a barrier that is useful for the noise, but also to filter the air emission, so as to reduce the pollution. In Valencia, what is interesting in Valencia is that we can try to use this kind of systems also in a port to measure the emission for the shipping. The ships produce a lot of pollutant, and Valencia is the largest harbor in Mediterranean Sea. So we will test the system for the emission by the ships. And in the Netherlands, using complex systems that permit to recognize each bogie, because it's possible, because when a train pass by, there is the possibility to read the number, and this is identified like the plate, which is the train and also the bogie. For that, they use also other systems, but I cannot go in detail. So, show some tests that was done in Rotterdam. That they test there for a lot of time, so they acquire a lot of data in the city. You see, I don't know if you, okay, you see here the microphones. Why 2 microphones? Because with 1 microphone you can have the sound level, but with 2 microphones we can have, like here, we have 2 ears, we can find the direction. So we can isolate the vehicles that is responsible for that level. Just to understand better, you see here the passage of all the car, but you see also the contribute of each passage to the other. So it is not easy to recognize the single vehicle when you have many vehicles in a queue. So the work was for that to, build using a fitting and recognize the single passages. And here you have some results that clearly explain what happened when many, many cars pass by. And you see that there are some vehicles that are high emitter. And again, here you can see it's possible to build a relationship between the sound level and the speed and acceleration, because we are able also to measure the acceleration. In the same time, using a camera, we can recognize also the plate and have the information about the emission of the cars. So we can have Euro 3, Euro 4, Euro 5, and also it's diesel or not. This information are the base. And again, in terms of numbers, you can see here the level, that the standard level with a distribution, but is greater than this. You can find the yellow area and after the red area. So it's not automatically that any high level is an high emitter, because sometimes there are different kinds. If you think about Harley Davidson has high level, but is with the law, because it's permitted. So you have to recognize if that car is out of the law or not. This is Barcelona, where we did another test, our pre-test, if you want, not the official one, because the official one, this is useful for the emission, for other information, because we did also measurements with a system on the car to know how much is the non-exhaust producing. So we have also this kind of measurements. Finally, we go to Florence, and this was the test in Parco delle Cascine in Florence, and we did this in June, 2 weeks of measurements for noise and for air emission. And in that occasion, I have the pleasure to show this group is by the Polish government, because I organized in Florence a meeting for the Polish Ministry of Environment, and it was the occasion to show them the results and the measurements just in the site. After this, we did the work with ARPAT for the air quality. That is different from air emission, because air quality means what the receiver, so what the citizen breathe. No? The emission is what the source produce. So we did 3 months of measurements, so a lot of data for that. This is the first time that I show this data, so you are lucky for that. And you can see the comparison between the different parts of Florence, particularly in the red is the Parco della Cascine, that is quite area practically, is a place, is a garden, is a park with a low level, but also you can see some peak, and this is corresponding to the emitters and what I said before. Okay, other data. So you see the variability of the results if you look for the single vehicles. So it's possible to reduce noise and improve the air quality acting on the peak of this, because the weight of this value is important. And okay, these are some results that show you what I said before, but maybe Sergio looks me too close, and I close.
Oh. Thank you, Gaetano. No, in fact, I was not looking you for suggesting to close, because you have still 2 or 3 minutes, and thank you for staying time. I just was looking at the monitor. So we have reached the end of the session, but we have still time for the round table. I would like that a round table could be a prosecution of the whole day. I see that many, maybe all of the presenters are here. And so before giving some questions or stimulation from myself, I would like to know if there are questions from the audience for the various presenters. Otherwise, we can still. Filippo, please. If you speak in the microphone, I think it's better. Oh, okay, we have the ice cream.
I have a question for my friend Gaetano. Congrats for your speech and your presentation. I was wondering about the upper or lower specification limits in the case both noise and air pollution are monitored. I mean, coming back to the presentation that we listened to today, what do you think about the existence or the feasibility of having an upper specification limit or something like that, that entails, that includes both air pollution and noise? This question comes after your presentation and what you said about monitoring both the one and the other class of pollution.
Okay. It's a difficult point because we went to Brussels and we met the European, I don't know if Marco and the colleague that I met there in Brussels for NEMO project, because we did like a meeting with all the different directorate, so DG Movie, DG Research, DG Environment, and so on. Because it's not easy to fix a number, considering that the market is an open market. So you have cars that are, and motorcycles, that they have different emission. So you have Euro 2, 3, 4, and so on. And also at the same time, different levels of noise. And it's quite difficult to fix a behavior for the cars. So how much you can accelerate, how much is the maximum. So the idea in the project at this point is not to make a fee for the car, but send a letter. So Municipality of Florence, we just to have an idea, we did a test for 10,000 of vehicles in Florence, selecting 10,000 vehicles because we acquired data for more than this. And for each vehicles, we know everything about it. I mean, we know who is, where live, what is the car, and so on. And it's possible to, with a connection between Municipality of Florence and the Ministry of Transport, and it's normal in the city when you have the laser that check your speed, but it's the first time that we do this for a new application like this. We will send, Arnaldo and colleagues will send letters to these people to push them to maintain better the vehicles. So this is like a moral suasion, just to push them to improve the quality of the city. In the future could come also a fee. And have you seen I showed before, the Austrian that put this in the highway? Also because there is a directive in Europe about the market surveillance, considering the scandal about Volkswagen and the others that produce cars and declare the Euro 5 or Euro 6, and after they rearrange the software to recognize the test and permit to the car to do different results in different conditions. And for European Commission, this was very, very important. So now there is a directive for that, and the device that we are developing here will be used to make this market surveillance. So is it difficult to fix everything? But the road is, it's not laying already, but we are laying a new road for that.
Thank you. Thank you very much. Other questions, comments, or something to add? Raffaella.
Only a curiosity. Are there privacy problems, issues? Because I was wondering how you can track everything of people passing on the road.
Obviously, there are a lot of problems for privacy. In fact, we don't have the images of the people that drive, and this is the key. but it's possible to have the images of the plates. The privacy came after, when you have to connect the plates with the people. But this is for public reason, so it's possible to do that if the management of this is in the hands of a municipality. So, but this was another big point and can give some problems for the development of these kind of things.
Other questions, comments? I want to start a possible discussion, just making a kind of a recap of what we have heard today, what we have also watched on the screen. Marco Paviotti this morning started with a question. Say, are tires and road surfaces the best solution to noise? But then the presentation of projects move around the question, of course not answering to the question, it would be too easy, but adding other questions or adding other elements. I remember that Filippo talked about the life cycle assessment of materials, products, and so on. I remember that Karsten talked about the holistic and optimization connected to a holistic approach. And finally, the title of some slides from Gaetano, that is a real-life environment. That suggests us that environment is a complex issue, and as all the complex problems can have a complex solution, not an easy one. And maybe the holistic approach can be this solution, but also the combination. That's why the networking is important. So what is the things that I want to share with you, but that I want also to ask the opinion of all of you, included the audience, not only the presenters, moving from your own experience. When answering to his questions at the end of his presentation, Marco Paviotti told us that for roads, tires are the best cost-effective solution, and he demonstrated this. But he said also that not he, but we all have seen in the other presentation, and also in his presentation, that it is better if this best solution, when you consider it alone, separated by the other, it becomes better if you consider it combined with other solution. It means that, okay, for roads, tires are the best if you consider one and the other separated. But if you combined, you understand that if you combine with the surfaces, I think that Daniele agree with me, because in his presentation and in the project they talk about this. And also with the project from Paris, from Bruy Paris, that Antoine illustrated us, we see that also the thermal effects can be combined. Francesco told us about how the tram noise together with the traffic noise can be analyzed and possibly solved together. So, I mean, the result of all this project, and in the frame of the project in which you are involved for the presenters, but in the experience on everyone, do you think that this can be the real solution? I mean, the holistic solution, a solution that consider the real-life environments as Gaetano presented and introduced us, and if yes, please add some suggestion for those that maybe are going to prepare new application for new projects. Maybe many of us are not thinking to stop in working on funded project, and maybe this is the occasion. We have the opportunity now to collect some idea and to create a new partnership or also new programs for application in the next future. So Okay, I hope to be clear in my intention, and I hope you could answer to this. Who's first?
Just me, because I'm here, but the first point that there are so many variables that is not possible answer with just one answer to you. And also, I cannot say that tires are better than road and vice versa, because depending on the situation. Have you seen that in Paris during the night, the results were quite good respect to the day, why? Because the speed is higher, and this is the key. Tires could be a general approach to the problem, also with a low speed maybe, and for the road action you need at least 40 kilometers per hour, or now maybe 30, because this threshold is moving with the size of the tire. But in any case, I mean, in the city, if you have high speed means greater than 40 maybe, is important, the road. And also, what is the quality of the maintenance of our road? There are roads, if you analyze the roads, you have 14 dB of differences. So why, and I sometimes participate to meetings with the road infrastructures owners and tire producers, and what the tire producers say to the owner infrastructures, why we have to work on the tires if you have a 14 dB of differences? Why, and Volkswagen and the other guys, why we have to spend 6 billion euro to reduce over 1 dB the noise of my engine if the differences in the road is so high? So I believe that we have to work on the road, at least to reduce and improve, reduce the distress of the road and improve the quality of the road. But this is the basic. After this, we can discuss about tires and so on. Otherwise, if you go around and you go in Rome is a classical example for that, or many other cities. I don't know, in Florence, I don't want to say that is like Rome, but there are roads in which the differences of the levels is very high. And why we have to spend a lot of money in new research if the normal maintenance can improve a lot. The second point is who pay, because this is the point. Who pay? We pay, the citizen, in any case, because the research of the industry came from the money that the industry put in that, but also from the help of European Commission, at least in Europe, but also the same is in Japan or in USA. So the cost of the new tires depends on the research. Is nothing, just easy to do that. I know that Carsten did a lot of work to improve the quality of the product, and so on. So who pay? Because in Italy, and we have this experience, we have a lot of law, we have a reclamation plan, the action plan, but how many are the cities that after the zoning produce a noise mapping? A noise mapping, the action plan and the reclamation plan. 38, 45, depending on the year in which you check this. And a lot of them are in Tuscany, not in all Italy. And this means that the law is not enough. Meeting like this, and not only with us, but also with the people, with the public administration and so on, can underline the awareness about the health effects that Marco underlined with DALI and so on. Because if the data coming from European Commission say that every €1 that you spend in action plan, you save 29. So if I have seen the president of the Tuscany region that disappeared, but it was few seconds in the room, we have to underline this for them. Because when they put the agenda of the program, they have to take into account that they know many questions about the air quality or many other points, but where is noise? So this is, I add this point to your comments.
Yeah, I think we should, or we could, be optimistic, not a little bit more than you. Otherwise, Because if we are realistic, strictly realistic, you're perfectly right. But we know that something can be done, including the improvement of the maintenance of the roads, of course, starting from there. There are places where they do the maintenance properly, and we can move from there. Other opinions, questions? Carsten, please.
Yes, thank you. Gaetano, I completely agree with you that we should maybe look at each situation and identify what is the most important measure. And there might be situations where it is the tire. There might be situations where is it a low road noise surface. There might be situations where it's just like fixing the potholes. And we've also seen some slides today, I think it was in the Bruy-Paris presentation, where people complained about the scooters. So maybe there are situations where we just need to take away the scooters. But there is no general solution which work for all situations, and we have to be aware of that. And another point I want to add, coming back to your question from the beginning regarding the holistic approach we need to take. And I guess coming from the tire industry, this is very natural for me, because I guess in the presentation I showed today, you've seen that for us this is very important, because we can never just focus on one aspect of our product. We always have to balance everything. And I think this is something where, for the tire side as well as for the road side, we need to be honest and realize that we have to operate in a holistic environment. And it's easy to say, oh, we can gain 4 dB from the tires, or we can gain 10 dBs from the road. But this is maybe not, if we take a holistic approach. Then we might have other requirements that at the same time we want to reduce rolling resistance by 10%. And that maybe is possible, but it's maybe not possible if you want to reduce noise at the same time. And we have to be aware of these constraints, and we should be honest in what we are doing and communicate it that way, and draw the right conclusions from that, I think.
Yeah. Thank you, Carsten. Thank you. And let me remember, before giving the floor to Marco, that I want to say thank you, Marco, for still being here after all this long day. Let me remember that some other projects have been funded and conducted in the past year, including the public participation. And I think that the soundscape approach with all questions regarding noise, but not only noise, regarding perception of places, and the association of people and places, as Gaetano said before, and the public participation, not only the stakeholder, also the public participation to the project and to the solution, to the choice of solution, could be another point that go in the right direction. Just for remember some project, I remember the Monza project, one recent project where some urban area will be redesigned or requalified according to a process, a public process. Okay, Marco Paviotti is still here. We have mentioned you very many times in this discussion, always remembering the good and stimulating words you said at the beginning and starting from them for discussing. So we give you the floor again for your
first of
very
all,
qualified opinion, Marco. Nice to have you here.
That's why we are. This is what. Can you hear me, Sergio? Can you hear me?
Yes, perfectly.
Yeah, okay.
Go on.
So first of all, that's the reason why I'm paid for. No, I'm paid to stimulate the debate. Otherwise, it's usually to work in the commission. I have two things, which link to different presentation and to this discussion. And it's the first one concerns the road side. I heard this morning that there are different components, and just noise is one of the components when you lay a road surface. And Gaetano now reminded us that it's also a question of maintenance. It's something that again needs some disclosure of culture, so some learning process for the local authorities, I believe. I personally have to share this experience that I have. I tried already some years ago to start, to initiate, to push at the CEN level, so the Comité Européen de Normalisation and standard, a standard for the classification of roads. And I said, I'm here because of the noise, but I think the best is that you develop a classification of the roads, which takes into consideration the different parameters you have there, the skid resistance and the noise as a minimum. And I know that they are basically finalizing the road classification for noise. And I know this from the road authorities, from the road research authorities with whom I work, but not the other ones. And I think it's a question of culture. The local authorities, the ones that are drafting the terms of reference for repaving a road, they are not aware of all the potential and possibly, that's my perception from Brussels, and possibly the fact that they are used to use specific road surface in that situation brings them more confidence that that's the right choice because they have paved that way for the last 20 years. And this doesn't allow the new products that shall be good on all parameters. When I'm talking about noise, I never have in my mind that there shall be a road which is good only for noise. Otherwise, it's very simple, I think. No, you can have just a flat cement road, and that's the smoothest road you can have, and that's the problem solved. So nobody will ever take this. The other is the parallel on the tire side. On the tire side, with the other 4 or 5 different colleagues that look at the tire issue in the commission, it's already since quite some years that I'm linking and trying to connect all the different parameters exactly, but it's easier. And in that sense, it's easier because we have debates that start and end in Brussels around the cafeteria that I told you. And it is not a joke because our offices and the office of the European RTMA, tire and road RTMA, rubber and tire manufacturers, is just opposite of our street, and we are using the same coffee shop. So it's really a business that is there. Why? Because in that case, the companies are all grouped there, and they are well linked. But it's not something that happens at local authorities level. The municipality that is having the terms of reference for the specific road surface is not linked to Rue Paris, or is not linked to, I don't know, Florence municipality.
Thank you, Marco. Thank you very much. Other question? I think that what Marco said is a good good explanation, or one possible good explanation of the problem. And what else, please? Can you tell your name, please?
Yes, thank you. I'm Claudio Guarnaccia from University of Salerno.
Thank you,
thank you all for this wonderful day, very interesting. My comment or question is about drivers' behavior and autonomous vehicles. We did some simulation in Salerno, very simple simulations, and we found that the effect of a driver's behavior on an average origin-destination path can be more than 1 dB. That is greater maybe of some of the data that we found today. Did any of the partner of the project do some work on this? Because my feeling is that once we will find the best mixture for asphalt, the best tire, and the best holistic solution for the problem, then we will have to deal with people that should implement these solutions.
Thank you, Claudio. Other questions, comments, opinion? Someone can answer to or comment what Claudio asked. Gaetano, you want to say something?
I can observe what already I show about the numbers that you see with the spread of the results. That is the behavior of the people. Without autonomous, maybe some behavior will be, more controlled, if you want. Because already, if you use the car, and some new car, you have this tool. The car give you feedback if you move in one direction or you are outside and so on. So I believe with the new car, this will be more and more. The electronics in the car will increase a lot. The road will be a smart road that we speak with. So all these things will control more the behavior of the people. But in any case, remain the freedom of the driver. Nobody can say to the driver to stop any electronics and do what he wants. So this is, again, the awareness of the problem. So you have to build more aware in the people about the effects of their behavior, not only for the noise, but also for the safety.
Thank you. Other comments on this? We have one from Filippo and then one from Antoine in connection. Please, Filippo.
The answer to your very interesting question is at least twofold. From a certain standpoint, I agree with Gaetano when he talks about freedom. Freedom as a source of negative impacts. But there is the other side of the medal. With more and more autonomous vehicles, there will be more and more damages to the structural state of the pavement because of the reduction of the wandering effect. All we know that Francesco likely is going to put his right hand of the vehicle close to the shoulder. In contrary, Roberto usually drives close to the median between two opposite directions. So, in the end, having more and more autonomous vehicle will imply the reduction of the expected life of the pavement because of the reduction of the variance of the Poisson curve or the distribution of the position. Just talking about 1 out of 1,000 effects. So from this standpoint, freedom versus autonomous vehicle will be a battle between positive and negative effects. And if you are interested about this topic, you will find a lot of research already in place, completed also through validation, through experimental validations. So congrats again for your interesting question.
Good. I think we all congrat for this. When there are good results and good ideas, I think that must be shared also the satisfaction about that. I agree with Filippo so much. So we have another connection with from remote from Antoine of Bruy Paris. I don't know if he is connected. I ask the technician.
Yes. I hope you can hear me.
Yes. Okay, Antoine, please go on.
I just want to say a word about the experimentation ongoing in France about the noise radars, which seems to, especially among local authorities, they seem to have a great expectation on the possibility of automatic sanction on the noisiest vehicles. This asks, I think, lots of questions. First of this question, if we had to build up that kind of sanction system, I think it must be the sign that somehow we failed in raising enough awareness about how can I say that the health impact, the collective health impact of uncivil behaviors, focusing in Paris on motorcycles drivers, of course. And I think both are relevant, and we cannot imagine a society where you have only hope in technology and in automatic sanction. And in, of course, it asks a lot of questions in terms of technical aspects, in terms, as it's been said, about privacy, about individual freedom, about regulatory aspects as well, because we don't know where do we put the level of you are beyond the limits, and you will have to pay for that. So of course, especially in Paris, when you have all the streets covered with silent asphalt, when you have the speed limit at 20 or 30 kilometers per hour, when you have only electric engines, the problem of behavior will remain, of course. But I must insist, of course, as you said, it's a holistic approach that must be relevant.
Thank you, Antoine. So I see there is a kind of convergence on this idea and this approach, even from different point of view, of course, and different position in terms of optimistic or realistic position. We have very few minutes more for before closing the session. If there are some other contribution from some of you from the audience. Okay, let's think if you have something to say. In the meantime, I give you. We have one more. Marco. Marco again.
Yes, so heading towards conclusion,
yes,
reminding where we
course.
started this morning, but also defending. We have the Environmental Noise Directive, colleagues. We have the Environmental Noise Directive since 20 years. And the objective of the Environmental Noise Directive is to link all these different actions. It is written since 20 years in the law, linking the solution at the source with the local solutions and letting the local authorities, the competent authorities, drafting maps, not just to send this to us in Brussels or to the European Management. It's there for their own use, for the local authorities to use and to understand, depending on the situation, which is the right intervention, and therefore draft the action plans. I think, again, it's a question of sharing more and more the knowledge that you have developed in this year. But the answer is there. The answer is there, and it's there since 20 years. Just use it. I'm sorry, I'm in charge of the directive and I have to defend it, but I'm happy to defend it.
Okay, thank you, Marco. I think that this can be also the final words, sharing the knowledge that we are developing. I can think with this lapidarian sentence, we can close this event, this final event, with the hope. Let me share the hope to see you all again in next future at the final events of the other projects that we are presenting and we are networking with. And just a few before saying good afternoon or good evening, I have to remind to the TCA, the acoustician that are also attending this event for getting the credits, that according to the program at 4:30, but you can start from now, as I think that they are distributing our colleagues. I say thank to them for this. Not only make a very perfect scientific secretary of the event, but they are also managing the collection of questionnaires. They are distributing, they can start distributing the questionnaires. You have to fill them and give back to them as you go and put your signature, okay? This is what you have to do if you are a competent technician, an Italian competent technician in the Enteca archive, and you want to get these hours for credits, as credits. And okay, Arnaldo, if you want to say, okay, Arnaldo suggests not to copy. And if you want to close, you are the host, and so I think the last word can be yours.
No, we finished. No, nothing to say. Only thanks everybody. Thanks all. I think that's a great day and a wonderful sharing experience in this afternoon. Thanks to Marco Paviotti for staying with us all day. It's important for us to see you and hear you. And thanks again, and see you later. And hope for see you for the next project, for the next chance to stay together with a new project, a new idea.
Let me also say thanks to the technician, to the staff, to the technical staff. They have assisted us and supported us also with the remote connection perfectly in solving the problem. One of them is one of my old students, but nevertheless, he worked well and everything functioned at best. Thank you very much to you all, and see you soon.
Thank you.
Have a nice afternoon. Enjoy Florence for those that are going in the center.